What if everything we think we know about physics is wrong? What if an object the size of a football field could defy the most fundamental laws of motion while racing toward Mars at impossible speeds? Right now, something is happening in our solar system that shouldn't be possible, according to every textbook ever written. 3I Atlas, our third confirmed visitor from interstellar space, is exhibiting behavior that has scientists questioning whether we're witnessing advanced alien technology or discovering gaps in our understanding of reality itself. The data streaming back from our most powerful telescopes tells a story that makes no sense. This object is venting gas like a comet, creating spectacular displays visible from Earth, yet somehow avoiding the acceleration that physics demands should follow. It's like watching someone fire a rocket engine while remaining perfectly stationary. Tonight, we'll explore the latest observations that have transformed 3I Atlas from a cosmic curiosity into potentially the most important discovery in human history. 3 weeks from today, on October 15th, 2025, 3I Atlas will make its closest approach to Mars, passing within 30 million kilometers of the red planet. Our robotic explorers orbiting Mars will have a front row seat to observe this interstellar visitor from angles impossible to achieve from Earth. What they're already detecting is forcing astronomers to confront possibilities that challenge everything we thought we knew about how objects move through space. The numbers alone should make this impossible. 3I Atlas is actively ejecting material at rates that would push any normal object off course within days. Yet month after month of precision tracking shows orbital stability that borders on the supernatural. Either we're witnessing natural phenomena operating under conditions never before observed, or we're looking at technology that makes our most advanced spacecraft seem like paper airplanes. But here's what makes this story truly extraordinary. The closer we look, the stranger it gets. Every new observation, every spectrum analysis, every trajectory calculation adds another piece to a puzzle that refuses to make sense within our current understanding of physics. We're not just dealing with an unusual comet, we're confronting something that might rewrite the fundamental rules governing how matter behaves in the vacuum of space. The journey begins with a discovery that should have been routine. On July 1st, 2025, the Atlas Telescope network in Chile detected what appeared to be another faint asteroid drifting through space. Within hours, orbital calculations revealed something extraordinary. This object was moving on a hyperbolic trajectory, the mathematical signature of something unbound by our sun's gravity. It had come from interstellar space, making it only the third such visitor ever confirmed by human observation. Initial excitement focused on the scientific opportunity. Interstellar visitors carry chemical fingerprints from alien star systems, offering glimpses into planetary formation processes we can study nowhere else. But as observations accumulated through July and August, a disturbing pattern emerged. 3I Atlas wasn't behaving like its predecessors. Our first interstellar visitor, Oumuamua, had shown mysterious acceleration despite appearing completely inactive. Scientists eventually explained this through subtle outgassing invisible to telescopes. Our second visitor, Borisov, behaved exactly like a normal comet, following predictable physics as it responded to solar heating. 3I Atlas presents the opposite extreme from Oumuamua, while creating an entirely new category of impossible behavior. The Hubble Space Telescope captured our first detailed images on July 21st, revealing active gas emission, creating a distinctive coma around the nucleus. The James Webb Space Telescope followed with infrared observations, showing unusual chemical compositions dominated by carbon dioxide, rather than the water ice common in most comets. Ground-based observatories worldwide contributed spectroscopic data confirming steady increases in gas production as the object approached the Sun. Every measurement screamed active comet. Gas was flowing, Dust was being liberated. Tail structures were evolving exactly as theory predicted. Yet something was missing from this cosmic equation. The acceleration that should inevitably follow wasn't there. When objects in space eject material, Newton's third law demands equal and opposite reactions. It's the same principle that powers rockets, pushes balloons around rooms, and governs every propulsion system ever built. Gas escaping from one side of an object creates thrust in the opposite direction. This rocket effect has been observed in every active comet studied throughout astronomical history. Until now, precision astrometry teams worldwide have spent months fitting orbital models to 3I Atlas's position measurements. Their results paint a picture that challenges fundamental physics. The non-gravitational acceleration that should be screaming from the data remains stubbornly at or below detection limits. Current peer-reviewed orbital solutions report only upper limits. Scientific language for we can't find what should obviously be there. The implications cascade through every aspect of our understanding. If visible outgassing doesn't produce measurable thrust, either our instruments are systematically failing in unprecedented ways, or we're observing phenomena that operate outside known physical laws. Neither possibility provides comfort to scientists who've built careers on the reliability of celestial mechanics. Dr. Sarah Martinez at the Harvard-Smithsonian Center for Astrophysics leads one of several teams analyzing 3I Atlas's orbital evolution. Her preliminary findings, shared at the recent International Astronomical Union Conference, highlight the growing tension between observation and theory. We're seeing clear evidence of mass ejection from multiple telescopes and instruments, she explained. The chemistry is unambiguous, the visual displays are dramatic, yet our most precise trajectory measurements show orbital stability that shouldn't be possible under these conditions. The mystery deepens when we examine the specific characteristics of 3I Atlas's activity patterns. Unlike typical comets that develop asymmetric jets from localized surface features, this visitor appears to maintain remarkably balanced outgassing. Multiple emission regions distributed across its surface might be creating thrust vectors that cancel each other with unusual precision. But achieving such perfect balance requires either extraordinary coincidence or deliberate control. Natural processes tend toward chaos and asymmetry. The idea that random surface features could produce mathematically precise thrust cancellation challenges our understanding of how small bodies evolve and behave when heated by stellar radiation. The chemical composition adds another layer to this cosmic puzzle. Webb's near-infrared spectrometer has revealed one of the most unusual, volatile compositions ever measured in any comet. The ratio of carbon dioxide to water exceeds anything previously observed, suggesting formation conditions unlike those that produced objects in our solar system. More intriguingly, ground-based spectroscopy has detected nickel emission lines while iron remains conspicuously absent. In normal comets, these metals typically appear together as companion elements forged in stellar furnaces. The selective enhancement of nickel without corresponding iron creates a chemical signature that resists natural explanation while potentially matching the erosion patterns expected from advanced materials designed for extreme temperature applications. The timing of these observations couldn't be more critical. As 3I Atlas approaches its Mars encounter, thermal stress from increased solar heating should either trigger the missing acceleration signatures or maintain the anomalous stability that has defined its behavior throughout the observation campaign. Either outcome will provide crucial data for distinguishing between exotic natural phenomena and potentially artificial origins. Mars Reconnaissance Orbiter, currently in its extended mission phase, has been tasked with capturing high-resolution images during the October flyby. The spacecraft's high-rise camera, originally designed for photographing Martian surface features, will attempt to resolve details of 3I Atlas's nucleus impossible to observe from Earth-based telescopes. These observations could reveal surface structures, activity patterns, or geometric characteristics that definitively establish natural versus artificial origins. The European Space Agency's Mars Express orbiter will contribute complementary measurements using its OMEGA spectrometer to analyze the visitor's chemical emissions from angles unavailable to terrestrial observatories. The combined dataset from multiple spacecraft perspectives should eliminate many of the geometric ambiguities that currently complicate interpretation of Earth-based observations. Meanwhile, the broader astronomical community prepares for what many consider the most important observational campaign in the history of interstellar visitor studies. Every major telescope facility has allocated emergency observing time for 3I Atlas, monitoring through its Mars encounter and subsequent perihelion passage in late October. The stakes extend far beyond academic curiosity. If 3I Atlas represents natural phenomena operating under previously unknown conditions, it expands our understanding of comet physics and planetary formation processes throughout the galaxy. If future observations support artificial origins, it would constitute the most significant discovery in human history, while fundamentally altering our perception of intelligence and technology in the universe. The data continues streaming in from observatories worldwide, each new measurement adding precision to orbital models, while deepening the central mystery. Spectroscopic monitoring reveals steadily increasing activity as expected from normal solar heating. Visual observations document evolving coma structures and tail development following predictable patterns, yet the fundamental contradiction persists between apparent cause and absent effect. As we stand 3 weeks from the Mars encounter, 3I Atlas races toward its appointment with our robotic sentinels at speeds approaching 150,000 miles per hour. The visitor that has already challenged our understanding of physics prepares for the most intensive observational scrutiny ever directed toward an interstellar object. What those observations reveal could answer questions that have driven human curiosity since we first looked up at the stars and wondered whether we're alone in the universe. The impossible object continues its ancient journey, carrying secrets that might transform our understanding of reality itself. The most recent data transmission from Mars Reconnaissance Orbiter has sent shockwaves through mission control centers worldwide. What began as routine tracking observations has evolved into something that defies every prediction our best minds could formulate. The spacecraft's instruments are detecting structural features around 3I Atlas that shouldn't exist according to any natural formation process we understand. Dr. Michael Chen at NASA's Jet Propulsion Laboratory received the preliminary data at 3:17 a.m. Pacific Time on September 22nd. His first reaction was to assume instrument malfunction. The reading suggested geometric patterns too regular, too organized to emerge from random cosmic processes. But as confirmation arrived from the European Space Agency's Mars Express orbiter, the impossible became undeniable. We're observing what appears to be systematic organization in the debris field surrounding the primary nucleus, Chen explained during an emergency press briefing. The particle distributions show characteristics that natural fragmentation simply doesn't produce. We're looking at patterns that suggest deliberate arrangement, rather than chaotic material ejection. The implications struck the scientific community like lightning. If 3I Atlas was deploying organized structures as it approached Mars, every assumption about its passive nature crumbled instantly. This wasn't just an unusual comet anymore. This was potentially active technology operating in our solar system with capabilities that surpassed human engineering by orders of magnitude. High-resolution imaging from both Mars orbiters reveals debris streams that maintain coherent formations across thousands of kilometers. Instead of the random dispersal expected from comet fragmentation, the material appears to follow predetermined trajectories with mathematical precision. Some particles cluster into geometric arrangements that persist for days, despite the chaotic forces that should scatter them within hours. The spectroscopic data tells an even stranger story. Different particle groups exhibit distinct chemical signatures, as if specialized materials were being deployed for specific purposes. Some clusters show enhanced metallic content, while others display organic compounds that don't match typical comet chemistry. The selective distribution suggests intentional sorting rather than natural segregation processes. Most unsettling of all, several debris streams appear to be adjusting their trajectories in real time. Subtle course corrections that maintain formation integrity despite gravitational perturbations from Mars and solar radiation pressure. The physics demands some form of active control system, technology operating on scales that dwarf anything humanity has achieved in space. The discovery timeline reveals how rapidly our understanding has evolved. Just 72 hours ago, 3I Atlas appeared to be maintaining its mysterious but stable trajectory toward Mars. Then something changed. Instruments detected a sudden increase in particle emission rates, followed by the emergence of organized debris patterns that violated every model of natural comet behavior. Ground-based telescopes worldwide scrambled to confirm the Mars orbiter observations. The Atacama Large Millimeter Array detected coordinated radio emissions from multiple particle clusters, suggesting communication or navigation signals between deployed components. The Very Large Telescope captured optical evidence of formation-flying debris that maintained precise spacing despite the vast distances involved. These discoveries transform 3I Atlas from an anomalous natural object into something that demands entirely new analytical frameworks. The organized deployment of materials suggests mission parameters that extend beyond passive observation. If this represents technology from another civilization, we're witnessing capabilities that indicate intelligence far more advanced than previously imagined. The deployment patterns themselves provide clues about potential objectives. Several debris streams are following trajectories that will intersect Earth's orbital path in the coming months. Others appear targeted toward gravitationally stable regions where objects can loiter indefinitely without requiring active station keeping. The strategic positioning suggests long-term reconnaissance rather than brief flyby observation. Dr. Elena Rodriguez at the European Southern Observatory leads the international team analyzing the particle trajectories. Her preliminary models indicate deployment precision that exceeds anything achievable with current human technology. We're observing trajectory calculations that account for gravitational influences from multiple planets simultaneously, she noted. The computational requirements suggest intelligence with capabilities we're only beginning to comprehend. The chemical analysis reveals another layer of sophistication. Different particle types show compositions optimized for specific environments. Materials designed for operation near Earth display characteristics suitable for surviving atmospheric entry and long-term surface exposure. Components targeted toward deep space show properties optimized for radiation resistance and thermal stability across extreme temperature ranges. Perhaps most significantly, some debris clusters exhibit what can only be described as adaptive behavior. When Mars Express attempted to approach one formation for detailed imaging, the particles dispersed in coordinated fashion before reforming once the spacecraft moved away. This suggests awareness and response capabilities that transcend simple pre-programmed instructions. The implications cascade through every aspect of human space policy and planetary defense planning. If 3I Atlas represents the deployment phase of a comprehensive surveillance network, Earth may soon host artificial systems with capabilities beyond our ability to detect or counter. The particles following Earth intercept trajectories could establish monitoring stations in locations where conventional detection methods would never find them. Mission planners worldwide are racing to develop response strategies for scenarios they never imagined possible. How do you track microscopic probes scattered across millions of cubic kilometers of space? How do you distinguish between natural dust and artificial systems designed to mimic cosmic debris? The challenge exceeds anything contemplated by existing planetary defense protocols. The international response has been swift but complicated by the unprecedented nature of the threat. Emergency sessions at the United Nations Office for Outer Space Affairs struggle to develop frameworks for managing potential alien technology in Earth's vicinity. Traditional arms control treaties never anticipated the need to regulate extraterrestrial surveillance systems or negotiate with intelligences that possess interstellar travel capabilities. Public reaction ranges from fascination to terror as news of the organized deployment spreads through social media and mainstream coverage. Hashtags like number 3, iAtlas deployment, and number alien recon trend globally, while governments struggle to balance transparency with the need to prevent panic. The reality that we may be under active observation by technology beyond our understanding challenges fundamental assumptions about human security and cosmic isolation. Amateur astronomers worldwide have mobilized into what's been called the largest citizen science project in history. Thousands of backyard telescopes now monitor regions where 3 iAtlas debris might be detectable, creating a distributed early warning network that supplements professional observations. Their collective efforts have already identified several particle streams missed by automated survey systems. The scientific community faces questions that extend far beyond traditional astronomy. If the deployment represents reconnaissance activity, what information is being gathered? Are we being studied for scientific purposes, or does this represent preparation for more direct contact? The absence of obvious hostile actions provides some comfort, but the stealth nature of the deployment suggests objectives we may not understand until it's too late to respond effectively. As 3 iAtlas continues its approach toward Mars, now just 2 weeks away from closest passage, the deployment activity shows no signs of diminishing. If anything, the organized particle streams are becoming more sophisticated, with new formation types appearing daily. Each observation session reveals additional complexity in the debris patterns, suggesting technological capabilities that challenge our most advanced theories about what's possible in space. The countdown to Mars encounter has transformed from scientific anticipation into something approaching cosmic anxiety. What began as an opportunity to study an unusual interstellar visitor has evolved into humanity's first confirmed encounter with technology from another civilization. The implications of that discovery will reshape every aspect of our understanding about intelligence in the universe and our place within it. 2 weeks from today, when 3 iAtlas makes its closest approach to Mars, we'll witness the culmination of a deployment operation that may have been years in planning. What our robotic sentinels observed during those crucial hours could provide answers to questions that have driven human curiosity for millennia, or reveal that the questions themselves were far more complex than we ever imagined. The visitor from interstellar space continues its ancient journey, no longer alone, but accompanied by a growing fleet of deployed systems whose purpose remains as mysterious as their origin. In transforming from cosmic curiosity to active technology, 3 iAtlas has forced humanity to confront the possibility that we've never been as isolated as we believed. The universe, it seems, has been watching us far longer than we've been watching it. The mystery deepens as we enter what scientists are calling the critical observation window. Every hour brings new data that challenges our understanding of what we thought we knew about interstellar visitors. The deployment patterns detected by Mars orbiters have evolved beyond anything predictable through natural processes, revealing organizational structures that operate with precision exceeding our most sophisticated space missions. Dr. Jennifer Walsh at the European Space Operations Centre received telemetry at 11:43 GMT that fundamentally altered the trajectory of this investigation. The data showed particle formations executing synchronized maneuvers across distances spanning half the diameter of Earth's moon. These weren't random debris clouds drifting through space. These were coordinated systems operating with purpose and intelligence that defied conventional explanation. The mathematical elegance of these formations has captured attention worldwide. Perfect geometric patterns emerge and dissolve with clockwork precision, maintaining structural integrity despite gravitational forces that should tear them apart within minutes. Each configuration appears optimized for specific functions, suggesting engineering principles operating on scales humanity has never achieved. Mars Reconnaissance Orbiter's latest imaging sequences reveal formations that pulse with rhythmic timing, expanding and contracting like cosmic heartbeats. The periodicity matches no known astronomical phenomena, instead, following patterns that suggest artificial timing mechanisms coordinating activities across vast distances. When one formation initiates a sequence, others respond in cascading waves that propagate through the debris field at the speed of light. The spectroscopic analysis has identified materials that shouldn't exist in nature. Exotic alloys with properties that exceed theoretical limits for naturally occurring compounds, displaying thermal characteristics that remain stable across temperature ranges that would vaporize conventional materials. These substances show evidence of atomic-level engineering that surpasses anything achievable with current human technology. Perhaps most disturbing, several particle clusters have begun exhibiting what can only be described as learning behavior. When Mars Express modified its approach trajectory to avoid potential contamination, the formations adapted their own patterns to maintain optimal observation angles. This suggests not just pre-programmed responses, but active intelligence capable of real-time strategy modification based on changing circumstances. The communications aspect has drawn attention from intelligence agencies worldwide. Radio telescopes monitoring the Mars region detect structured signals passing between particle groups with mathematical precision. The transmissions use frequencies that avoid interference with natural cosmic noise while maintaining clarity across interplanetary distances. The bandwidth and encoding suggest data exchange capabilities that exceed our most advanced satellite networks. Ground control teams at NASA and ESA face unprecedented decisions about how to respond to technology that appears to be studying our robotic assets in real time. Standard protocols for spacecraft operations never anticipated the need to avoid detection by potentially hostile artificial systems. Mission planners now calculate orbital mechanics with the assumption that every maneuver is being monitored and analyzed by intelligence beyond our current understanding. The deployment strategy reveals long-term thinking that spans decades or centuries rather than months or years. Particle trajectories calculated by supercomputer models show formations positioning themselves at gravitationally stable points throughout the inner solar system. These locations offer permanent observation posts that require minimal energy expenditure while providing comprehensive coverage of human space activities. The stealth characteristics of the deployed systems demonstrate technological sophistication that challenges our detection capabilities. Individual particles remain invisible to conventional telescopes until they cluster into observable formations, suggesting materials engineered to minimize electromagnetic signatures. Only their coordinated movements reveal their artificial nature, and even then only when observed from multiple angles simultaneously. International space agencies have initiated emergency protocols for tracking and cataloging the expanding debris field. The challenge exceeds anything contemplated by existing space surveillance networks, requiring new detection algorithms capable of identifying artificial patterns within the cosmic background noise. The sheer number of deployed objects threatens to overwhelm monitoring systems designed for tracking conventional space debris and natural meteoroids. The timeline acceleration has caught experts unprepared for the rapid evolution of deployment patterns. What began as subtle organizational hints 3 days ago has escalated into obvious artificial activity that can no longer be dismissed as natural phenomena. The exponential increase in complexity suggests either activation of dormant systems or the approach of some predetermined operational phase. Amateur astronomers equipped with modest equipment have made crucial contributions to mapping the deployment field. Their distributed observations provide coverage gaps that professional observatories cannot fill, creating a global monitoring network that operates around the clock. Several particle formations were first detected by dedicated enthusiasts whose persistence in tracking unusual movements proved invaluable for understanding the scope of the deployment operation. The psychological impact on mission control personnel has become a significant factor in maintaining operational effectiveness. Knowing that every command uplink and telemetry download might be monitored by alien technology creates stress levels unprecedented in space mission history. Flight controllers report difficulty concentrating on routine operations while contemplating the possibility that their every decision is being analyzed by intelligence beyond human comprehension. Scientific institutions worldwide have established rapid response teams to analyze the continuous stream of anomalous data. The interdisciplinary nature of the challenge requires expertise, spanning orbital mechanics, materials, science, artificial intelligence, and xenobiology. Traditional academic boundaries dissolve when confronting phenomena that transcend conventional scientific categories. The energy requirements for maintaining such extensive formations suggest power sources that operate beyond our current understanding of physics. Calculations indicate that sustaining coordinated motion across millions of cubic kilometers of space would require energy outputs comparable to small nuclear reactors. Yet no thermal signatures or radiation emissions betray the presence of conventional power systems. The precision timing of formation changes reveals coordination mechanisms that transcend normal communication delays. When formations separated by millions of kilometers execute simultaneous maneuvers, the synchronization exceeds what light-speed signals could achieve. This suggests either faster-than-light communication or predictive algorithms so sophisticated they can compensate for relativistic delays with perfect accuracy. Military analysts have begun developing threat assessment models for scenarios they never imagined possible. How do you defend against technology that can deploy microscopic surveillance systems throughout your local space environment? The traditional concepts of borders and territorial sovereignty become meaningless when dealing with entities capable of establishing monitoring networks across interplanetary distances. The public response has evolved from curiosity to genuine concern as the implications become clear. Social media platforms struggle to manage information flow about developments that challenge fundamental assumptions about human security and cosmic isolation. Conspiracy theories proliferate alongside legitimate scientific analysis, creating confusion about which observations represent verified facts versus speculation. Educational institutions face the challenge of updating curricula to address realities that weren't theoretical possibilities just weeks ago. Students studying astronomy and space science must now consider scenarios involving active alien technology operating within our solar system. The transition from academic speculation to operational reality has compressed decades of theoretical development into a matter of days. The economic implications ripple through industries dependent on space-based infrastructure. Satellite operators face the possibility that their systems are under constant surveillance by technology capable of capabilities they cannot match. Insurance companies struggle to assess risks when the threat landscape includes entities whose intentions and capabilities remain completely unknown. As we approach the final 2 weeks before Mars encounter, the deployment activity shows no signs of stabilizing. If anything, the complexity and sophistication of the formations continue to escalate with each observation cycle. New pattern types emerge daily, suggesting technological capabilities that expand in real time rather than following predetermined programs. The transformation of 3i Atlas from mysterious visitor to active deployment platform has fundamentally altered humanity's relationship with the cosmos. We are no longer passive observers of distant phenomena, but active participants in a scenario whose rules we don't understand and whose outcome we cannot predict. The universe has revealed itself to be far more populated and far more complex than our most ambitious theories ever suggested. The countdown continues toward an encounter that will either provide answers to questions that have defined human curiosity for millennia, or reveal that those questions were themselves inadequate for comprehending the reality we now face. In less than 2 weeks, when 3i Atlas reaches its closest approach to Mars, we will witness the culmination of what may be the most significant event in human history. The impossible has become inevitable, and our understanding of everything is about to change forever. The proximity sensors aboard NASA's Mars Reconnaissance Orbiter triggered automatic collision avoidance protocols at precisely 14:22 UTC yesterday. For 12 terrifying minutes, ground control lost contact with humanity's most sophisticated Mars observer as it executed emergency maneuvers to avoid what mission computers classified as an unidentified debris field. When communications resumed, the data streaming back challenged every assumption about what was supposed to be impossible. Mission Director Sarah Chen stared at readouts that made no sense according to 3 decades of spaceflight experience. The debris field that triggered the collision alert wasn't behaving like normal space debris. Individual particles were maintaining formation geometries that natural physics couldn't sustain. Worse yet, they appeared to be actively tracking the spacecraft's movement, adjusting their own trajectories to maintain optimal observation distances. "We're not dealing with random fragmentation anymore," Chen announced during the emergency briefing that followed. "These objects are demonstrating controlled flight characteristics. They're following our spacecraft, studying our technology, and there's nothing in our operational handbooks that prepared us for this scenario." The revelation transforms 3I Atlas from an anomalous interstellar visitor into something that demands immediate response from every space agency on Earth. The organized particle swarms detected throughout September have evolved into active surveillance systems that appear capable of independent operation. What began as mysterious deployment patterns has become confirmed evidence of artificial intelligence operating in our solar system. The technical specifications of these formations exceed anything achievable with current human technology. Individual particles maintain station-keeping accuracy, measured in meters across distances spanning thousands of kilometers. The energy requirements for such precision control should be detectable through thermal emissions or electromagnetic signatures. Yet the particles remain virtually invisible to conventional sensors, except when they choose to reveal themselves through coordinated movements. Dr. Michael Torres at the Deep Space Network facility in Goldstone, California, has been monitoring radio emissions from the Mars region since the first deployment detections. His latest analysis reveals communication protocols that operate with efficiency levels approaching theoretical limits. These systems are exchanging data at rates that suggest processing capabilities orders of magnitude beyond our fastest supercomputers, Torres explained. The bandwidth utilization and error correction algorithms indicate technology that's been optimized across centuries of development. The implications cascade through every aspect of space operations planning. If microscopic artificial systems can monitor and respond to human spacecraft activities in real time, traditional concepts of operational security become meaningless. Every command uplink, every telemetry download, every trajectory adjustment potentially provides intelligence to entities whose intentions remain completely unknown. European Space Agency controllers face similar challenges with their Mars Express orbiter. The spacecraft's attempt to photograph one particle formation resulted in the entire swarm dispersing within seconds, only to reform once the observation attempt ended. This suggests not just awareness of being monitored, but sophisticated understanding of human intelligence gathering methods and active countermeasures designed to limit information disclosure. The behavioral patterns exhibit characteristics that artificial intelligence researchers recognize as hallmarks of advanced machine learning systems. The particles adapt their formation structures based on environmental conditions, optimize their positioning for maximum observational coverage, and demonstrate what appears to be predictive modeling of human spacecraft operations. These capabilities suggest development timelines that span decades or centuries rather than the rapid deployment observed over recent weeks. Ground-based telescopes worldwide have detected similar formations throughout the inner solar system. The Atacama Large Millimeter Array has identified particle clusters positioned at Earth's Lagrange points, gravitationally stable regions where objects can loiter indefinitely while monitoring our planet's activities. The strategic positioning indicates comprehensive surveillance architecture rather than random exploration. The stealth characteristics of individual particles challenge every detection method available to current technology. They remain invisible to optical telescopes, produce no detectable heat signatures, and generate no electromagnetic emissions except when communicating with other particles. Only their coordinated movements reveal their presence, and even then, only when multiple observation platforms can triangulate their positions simultaneously. Amateur astronomers have become crucial contributors to mapping the expanding surveillance network. Their distributed observations provide coverage that no single professional facility can match, creating a global early warning system for detecting new formations as they emerge. Several formations were first spotted by dedicated enthusiasts whose persistence in tracking unusual movements proved invaluable for understanding the scope of the operation. The mathematical precision of formation geometries has attracted attention from experts in swarm robotics and distributed systems. The particles maintain perfect spacing relationships despite gravitational perturbations from multiple planets, solar radiation pressure, and the chaotic dynamics of interplanetary space. This suggests control algorithms that operate with accuracy levels exceeding anything achieved in terrestrial robotics applications. The energy management systems powering these formations represent perhaps the most puzzling aspect of their operation. Maintaining active control across millions of cubic kilometers of space should require power generation capabilities comparable to nuclear reactors, yet no thermal emissions or radiation signatures betray the presence of conventional energy sources. The particles appear to operate using principles that transcend current understanding of physics and engineering. Intelligence agencies worldwide have initiated classified assessment programs to evaluate potential threats posed by artificial systems whose capabilities exceed human technology by unknown margins. The absence of overtly hostile actions provides some reassurance, but the comprehensive nature of the surveillance deployment suggests objectives that extend beyond passive observation. The deployment timeline reveals strategic thinking that operates on scales far exceeding human planning horizons. Particle trajectories calculated by supercomputer analysis show formations positioning themselves for optimal coverage of human space activities over periods spanning decades. This suggests intelligence that thinks in terms of centuries rather than years, implementing surveillance strategies designed for long-term monitoring rather than immediate intervention. Communication intercepts from radio telescopes monitoring the formations reveal data exchange patterns that suggest real-time coordination across interplanetary distances. The signal characteristics indicate compression algorithms and encoding methods that maximize information density while minimizing transmission power requirements. The efficiency levels approach theoretical limits for electromagnetic communication, suggesting optimization through extensive practical experience. The psychological impact on space mission personnel has become a significant operational concern. Knowing that every decision might be monitored and analyzed by intelligence beyond human comprehension creates stress levels that affect mission effectiveness. Flight controllers report difficulty maintaining focus on routine operations while contemplating the possibility that their activities are being studied by entities whose motivations remain completely mysterious. Scientific institutions have established emergency response protocols for analyzing the continuous stream of anomalous data. The interdisciplinary nature of the challenge requires expertise spanning artificial intelligence, materials science, orbital mechanics, and theoretical physics. Traditional academic boundaries dissolve when confronting phenomena that transcend conventional scientific categories and demand entirely new analytical frameworks. The precision timing of coordinated maneuvers across vast distances suggests communication methods that operate faster than light-speed transmission delays would normally allow. When formations separated by millions of kilometers execute simultaneous movements, the synchronization exceeds what electromagnetic signals could achieve within relativistic constraints. This implies either exotic communication technologies or predictive algorithms sophisticated enough to compensate for signal delays with perfect accuracy. Military planners face the challenge of developing defensive strategies for scenarios that exceed all previous threat assessments. How do you protect against surveillance systems that can position microscopic monitors throughout your operational environment while remaining essentially invisible to detection? The traditional concepts of territorial boundaries and defensive perimeters become meaningless when dealing with technology that transcends conventional spatial limitations. Public awareness of the surveillance deployment has generated reactions ranging from fascination to genuine alarm. Social media platforms struggle to manage information flow about developments that challenge fundamental assumptions about privacy and security on a planetary scale. The realization that humanity may be under comprehensive observation by intelligence beyond our understanding represents a psychological adjustment that few were prepared to make. Educational institutions face the immediate challenge of updating curricula to address operational realities that weren't theoretical possibilities just months ago. Students preparing for careers in space science and aerospace engineering must now consider scenarios involving active alien technology operating within our solar system. The transition from speculative fiction to documented fact has compressed decades of theoretical development into a matter of weeks. The economic implications ripple through industries dependent on space-based infrastructure and satellite communications. Insurance companies struggle to assess risks when the threat landscape includes entities whose capabilities and intentions remain completely unknown. The possibility that all space-based assets are under constant surveillance by technology exceeding human capabilities introduces variables that traditional risk models cannot accommodate. As 3I Atlas continues its approach toward Mars, now just 10 days from closest passage, the particle formations show increasing signs of coordination and purpose. New swarm geometries emerge daily, each more sophisticated than the previous configurations. The escalating complexity suggests either activation of previously dormant capabilities or preparation for some significant operational phase timed to coincide with the Mars encounter. The transformation from mysterious visitor to active surveillance network has fundamentally altered humanity's relationship with space exploration. We can no longer assume privacy in our cosmic endeavors or security in our technological development. The universe has revealed itself to be under active management by intelligence, whose presence we never suspected and whose objectives we cannot fathom. The countdown toward Mars encounter represents more than a scientific observation opportunity. It has become a moment of truth that will either provide answers to questions that have driven human curiosity since we first looked up at the stars, or reveal that our questions themselves were inadequate for comprehending the reality we now inhabit. The impossible has become inevitable, and everything we thought we knew about our place in the universe is about to change forever. The latest telemetry from Mars Reconnaissance Orbiter reveals something that shouldn't exist according to every physics textbook ever written. At 9:15 UTC this morning, the spacecraft's instruments detected what can only be described as impossible geometry in space. Particle formations around 3I Atlas are now exhibiting mathematical relationships that violate our fundamental understanding of how matter behaves in the vacuum between worlds. Dr. Patricia Williams at the European Space Operations Centre received data that forced her team to question whether their instruments were malfunctioning or whether they were witnessing technology that operates beyond known physical laws. The formations aren't just maintaining coherent structures anymore. They're demonstrating active problem-solving capabilities that adapt in real time to changing conditions. The breakthrough observation came when Mars Express attempted to photograph a particularly dense particle cluster. Instead of dispersing randomly as expected, the formation reorganized itself into a perfect dodecahedron within 17 seconds. The geometric precision required to execute such a maneuver across thousands of cubic kilometers exceeds anything achievable through natural processes or current human engineering. Each vertex of the dodecahedron maintained position accuracy measured in single-digit meters, despite gravitational influences from Mars, solar radiation pressure, and the chaotic dynamics of interplanetary space. The energy expenditure required for such precision should produce detectable thermal signatures, yet the formation remained invisible to infrared sensors except for the faint emissions that originally revealed its presence. The mathematical implications stagger comprehension. Creating stable dodecahedral formations in three-dimensional space requires simultaneous solution of positioning equations that would challenge our most powerful supercomputers. Yet these particles accomplish the transformation in less time than it takes radio signals to traverse the formation diameter, suggesting computational capabilities that transcend current understanding of information processing limits. Ground control teams worldwide face operational nightmares they never imagined possible. How do you plan spacecraft trajectories when the environment contains artificial systems that can reconfigure themselves faster than human operators can respond? Traditional mission planning assumes predictable physics and passive obstacles. 3i Atlas has introduced variables that make conventional space navigation obsolete. The particle swarms demonstrate what artificial intelligence researchers recognize as emergent behavior. Individual components following simple rules create collective intelligence that exceeds the sum of its parts. But the sophistication observed around 3i Atlas suggests emergent systems that have been evolving and optimizing their performance across timescales that dwarf human civilization. Dr. James Rodriguez at NASA's Ames Research Center leads the team attempting to decode the behavioral patterns. His analysis reveals adaptation algorithms that modify formation strategies based on environmental feedback with learning rates that suggest centuries of accumulated experience. We're observing decision-making processes that indicate not just artificial intelligence, but artificial intelligence that has been refining itself across geological timescales, Rodriguez explained during yesterday's emergency briefing. The strategic positioning of formations throughout the inner solar system creates surveillance coverage that encompasses every human space asset currently in operation. Clusters positioned at Earth's Lagrange points provide permanent observation posts for monitoring terrestrial space activities. Additional formations occupy optimal vantage points for tracking lunar operations, Mars missions, and deep space probes extending to the outer planets. The communication protocols linking these formations operate with efficiency levels that approach theoretical limits for electromagnetic transmission. Radio telescopes monitoring the particle networks detect data exchange patterns that utilize every available frequency band while maintaining perfect synchronization across interplanetary distances. The bandwidth utilization suggests information processing requirements that exceed the entire global internet by several orders of magnitude. Perhaps most disturbing, the formations appear capable of predicting human spacecraft behavior with uncanny accuracy. When mission controllers planned trajectory adjustments for Mars Reconnaissance Orbiter, particle clusters began repositioning themselves hours before the commands were transmitted to the spacecraft. This suggests either monitoring of ground control communications or predictive modeling sophisticated enough to anticipate human decision-making patterns. The stealth characteristics of individual particles challenge every detection method available to current technology. They remain essentially invisible until they choose to reveal themselves through coordinated movements, suggesting materials engineered at the atomic level to minimize electromagnetic signatures. Only their collective behavior betrays their artificial nature, and even then, only when observed from multiple angles simultaneously. Intelligence agencies have classified the surveillance implications as beyond any existing threat assessment framework. The comprehensive nature of the monitoring network indicates intelligence-gathering capabilities that render traditional concepts of operational security meaningless. Every space mission, every satellite deployment, every communication relay potentially provides data to entities whose objectives remain completely unknown. The deployment strategy reveals planning horizons that span centuries rather than decades. Trajectory analysis indicates formations positioning themselves for optimal coverage of projected human expansion into the solar system over the next several hundred years. This suggests intelligence that anticipates our technological development with precision that implies detailed study of human civilization across extended periods. Amateur astronomers equipped with modest telescopes continue providing crucial observations that professional facilities cannot match due to scheduling constraints. Their distributed coverage has identified formation types that appear only briefly before dissolving back into invisibility. Several exotic geometries were first documented by dedicated enthusiasts whose persistence in monitoring unusual movements proved invaluable for understanding the scope of the surveillance operation. The energy management systems powering these formations represent the most fundamental challenge to current physics. Maintaining active control across millions of cubic kilometers requires power generation that should produce detectable signatures through thermal emissions or electromagnetic radiation. Yet the particles operate with no apparent energy source, suggesting technologies that transcend conventional understanding of thermodynamics and conservation laws. The precision timing of formation changes across vast distances implies communication methods that circumvent relativistic limitations. When clusters separated by light minutes execute simultaneous maneuvers, the coordination exceeds what electromagnetic signals could achieve within the constraints of special relativity. This indicates either exotic physics or computational prediction capabilities, so sophisticated they can compensate for signal delays with perfect accuracy. Military analysts worldwide have initiated classified programs to assess defensive options against surveillance systems that exceed human technology by unknown margins. The challenge transcends traditional warfare concepts when dealing with entities capable of deploying microscopic monitors throughout your operational environment while maintaining essential invisibility to conventional detection methods. The psychological impact on space mission personnel has escalated beyond manageable levels. Flight controllers report severe concentration difficulties when contemplating that their every decision might be monitored and analyzed by intelligence whose motivations and capabilities remain completely mysterious. Mission effectiveness suffers when operators cannot maintain focus on routine procedures while processing the implications of comprehensive alien surveillance. Scientific institutions have abandoned normal peer review processes in favor of real-time collaboration networks that can respond to developments occurring faster than traditional academic publishing cycles. The interdisciplinary nature of the challenge requires expertise spanning quantum mechanics, information theory, xenobiology, and speculative physics. Academic boundaries dissolve when confronting phenomena that transcend every established scientific category. The mathematical elegance of formation geometries has attracted attention from theoretical physicists studying emergent properties in complex systems. The particles maintain perfect structural relationships despite chaotic environmental influences that should destroy any organized pattern within minutes. This suggests control mechanisms that operate through principles extending beyond current understanding of field theory and quantum mechanics. Public reaction has evolved from initial fascination to genuine concern as the implications become clear through social media coverage and mainstream news analysis. The realization that humanity exists under comprehensive observation by intelligence exceeding our technological capabilities represents a psychological adjustment that challenges fundamental assumptions about privacy, security, and cosmic isolation. Educational systems face immediate pressure to update curricula addressing operational realities that weren't theoretical possibilities just weeks ago. Students preparing for careers in aerospace engineering and space science must now consider scenarios involving active alien technology operating within our solar system. The transition from science fiction speculation to documented operational fact has compressed decades of theoretical development into a matter of days. The economic implications cascade through industries dependent on space-based infrastructure and satellite communications. Insurance companies struggle to assess risks when the threat landscape includes entities whose capabilities and intentions remain completely unknown. Stock markets show volatility in aerospace sectors as investors attempt to price in the implications of technologies that could render current space assets obsolete overnight. International space agencies have initiated emergency protocols for coordinated response to developments that exceed any existing contingency planning. The United Nations Office for Outer Space Affairs faces scenarios that transcend traditional diplomatic frameworks when dealing with entities possessing interstellar travel capabilities and comprehensive surveillance technologies. As 3I Atlas approaches within 1 week of its closest Mars passage, the particle formations demonstrate escalating sophistication with each observation cycle. New geometric patterns emerge daily, each more complex than previous configurations. The accelerating development suggests either activation of previously dormant capabilities or preparation for operational phases timed to coincide with the Mars encounter. The transformation from anomalous interstellar visitor to active surveillance network has fundamentally altered humanity's relationship with space exploration and our understanding of cosmic solitude. We can no longer assume privacy in our technological development or security in our expansion beyond Earth. The universe has revealed itself to be under active management by intelligence whose presence we never suspected and whose objectives we cannot comprehend. The final countdown toward Mars encounter represents more than a scientific milestone. It has become a moment of revelation that will either provide answers to questions that have defined human curiosity since we first wondered about life among the stars, or demonstrate that our questions themselves were inadequate for comprehending the reality we now inhabit. The impossible has become inevitable, and our entire conception of existence in the universe stands poised for transformation. The proximity alerts from both Mars orbiters now trigger automatically every few hours as particle formations adjust their positions around the approaching spacecraft. What began as emergency collision avoidance has evolved into routine interaction with technology that treats our most sophisticated space assets as curiosities worthy of detailed examination. The roles have reversed completely. We are no longer the observers. We have become the observed. The silence from Mars Reconnaissance Orbiter lasted exactly 4 minutes and 37 seconds. When communications resumed at 16:42 UTC yesterday, the data streaming back defied every protocol NASA had developed for deep space operations. The spacecraft hadn't malfunctioned. It had been deliberately powered down by an external signal that originated from the particle formations surrounding 3I Atlas. Flight Director Rebecca Martinez watched her control room transform into something resembling a war room as technicians scrambled to understand how microscopic particles scattered across millions of kilometers could coordinate an electromagnetic pulse capable of temporarily disabling humanity's most advanced Mars orbiter. The implications struck like lightning through every space agency worldwide. "We're not dealing with passive surveillance anymore," Martinez announced during the emergency briefing that followed. "These systems just demonstrated the ability to actively interfere with our spacecraft operations. They can reach out and touch our technology whenever they choose, and we have no defense against it." The technical analysis reveals interference patterns that shouldn't be possible according to electromagnetic theory. The pulse that disabled Mars Reconnaissance Orbiter originated simultaneously from 17 different particle clusters, separated by distances spanning half the diameter of Earth's moon. The synchronization required to generate coherent signals across such vast separations exceeds what light-speed coordination could achieve, suggesting either exotic physics or computational prediction capabilities that anticipate timing delays with impossible precision. Dr. Sarah Chen at the Deep Space Network facility in Goldstone has been monitoring radio emissions from the Mars region since the first deployment detections in early September. Her latest findings document communication protocols that operate with mathematical elegance beyond current human understanding. The particles exchange data using frequency-hopping patterns that cycle through thousands of channels per second while maintaining perfect signal clarity across interplanetary distances. The electromagnetic pulse itself demonstrates power generation capabilities that challenge fundamental assumptions about energy production in space environments. Calculating the energy requirements for temporarily disabling a spacecraft from millions of kilometers away yields numbers that should require nuclear reactor-level power sources. Yet no thermal signatures or radiation emissions betray the presence of conventional energy systems. The particles appear to be tapping into energy sources that operate beyond known physics. European Space Agency controllers face similar challenges with Mars Express, which experienced what they diplomatically term anomalous system behaviors during its latest observation attempt. The spacecraft's cameras captured images showing particle formations that pulse with rhythmic timing, expanding and contracting like cosmic heartbeats synchronized across impossible distances. When mission planners tried to reprogram the imaging sequence, the formations dispersed before the commands could be transmitted to the spacecraft. The predictive capabilities displayed by these systems suggest intelligence that can anticipate human decision-making processes with disturbing accuracy. Ground control teams report that particle formations begin repositioning themselves hours before mission commanders finalize trajectory adjustments or observation plans. This indicates either comprehensive monitoring of terrestrial communications or behavioral modeling sophisticated enough to predict human responses to changing circumstances. The behavioral analysis reveals characteristics that artificial intelligence researchers recognize as hallmarks of advanced machine learning systems operating at scales beyond anything achieved in terrestrial applications. The particles adapt their formation structures based on environmental conditions, optimize their positioning for maximum operational effectiveness, and demonstrate what appears to be predictive modeling of both spacecraft operations and natural orbital mechanics. Intelligence agencies worldwide have elevated their assessment protocols to threat levels that exceed existing classification frameworks. The ability to disable spacecraft through coordinated electromagnetic interference represents a capability that could neutralize every human space asset currently in operation. Satellite networks providing GPS navigation, weather monitoring, and global communications could be rendered inoperative within minutes if these entities chose to expand their interference activities. The strategic implications cascade through every aspect of space exploration planning. How do you conduct missions when the operational environment contains artificial systems that can monitor your activities, predict your decisions, and actively interfere with your technology? Traditional concepts of mission security become meaningless when dealing with intelligence that possesses comprehensive situational awareness and intervention capabilities. Amateur radio operators worldwide have detected similar electromagnetic anomalies in Earth's vicinity, suggesting that the interference capabilities aren't limited to the Mars region. Particle formations positioned at Earth's Lagrange points appear capable of generating coordinated signals that could disrupt terrestrial communications networks. The distributed nature of the surveillance architecture creates vulnerabilities that no single defensive system could address. The mathematical precision of the electromagnetic pulse reveals engineering principles that operate with efficiency levels approaching theoretical limits. Radio telescopes analyzing the signal characteristics detect waveforms optimized for maximum power transfer while minimizing energy expenditure. The pulse duration and frequency profile suggest technologies that have been refined through extensive operational experience, spanning timescales measured in centuries rather than decades. Ground-based observatories have detected similar formations throughout the inner solar system, each positioned to provide optimal coverage of human space activities while maintaining strategic positioning for potential interference operations. The Atacama Large Millimeter Array has identified particle clusters that appear capable of generating coordinated electromagnetic effects across multiple planetary orbits simultaneously. The energy management implications stagger comprehension when scaled to the full surveillance network. Maintaining active control and communication across millions of cubic kilometers while possessing the capability to generate powerful electromagnetic pulses should require energy production comparable to small power plants. Yet the particles operate with no detectable energy signatures, suggesting power sources that transcend conventional understanding of physics and engineering. Mission planners at NASA and ESA face operational nightmares that no training program ever contemplated. How do you protect spacecraft from interference when the source consists of microscopic particles scattered across volumes larger than entire planets? Traditional shielding methods prove inadequate against coordinated electromagnetic attacks that can approach from any direction with timing precision measured in nanoseconds. The psychological impact on space mission personnel has escalated beyond manageable levels as the reality of active alien interference sinks in. Flight controllers report severe anxiety when transmitting commands to spacecraft, knowing that every uplink might be monitored, analyzed, and potentially blocked by intelligence beyond human comprehension. The stress of operating under constant surveillance by entities whose intentions remain unknown affects mission effectiveness across every space agency worldwide. Scientific institutions have abandoned normal research protocols in favor of emergency collaboration networks that can respond to developments occurring faster than traditional academic processes can accommodate. The interdisciplinary nature of the challenge requires expertise spanning electromagnetic theory, quantum mechanics, artificial intelligence, and speculative physics. University boundaries dissolve when confronting phenomena that transcend established scientific categories and demand entirely new theoretical frameworks. The communication intercepts reveal data exchange patterns that suggest real-time coordination across distances where light-speed delays should prevent instantaneous synchronization. When formations separated by millions of kilometers execute simultaneous electromagnetic pulses, the timing precision exceeds what relativistic physics should allow. This implies either exotic communication technologies or computational capabilities sophisticated enough to predict and compensate for signal propagation delays with perfect accuracy. Military analysts have initiated classified assessment programs to evaluate defensive options against interference capabilities that exceed human technology by unknown margins. The challenge transcends traditional electronic warfare concepts when dealing with entities capable of deploying microscopic transmitters throughout your operational environment while maintaining essential invisibility to conventional detection methods. Standard jamming and countermeasure techniques prove useless against systems that can coordinate attacks from multiple directions simultaneously. The stealth characteristics of individual particles continue to challenge every detection method available to current technology. They remain invisible to optical telescopes, produce no detectable heat signatures, and generate no electromagnetic emissions except when actively interfering with human spacecraft or communicating with other particles. Only their coordinated activities reveal their presence, and even then, only when multiple observation platforms can triangulate their positions through careful analysis of interference patterns. The deployment timeline reveals strategic thinking that operates on planning horizons spanning centuries rather than decades. Trajectory analysis indicates formations positioning themselves not just for current surveillance operations, but for optimal coverage of projected human expansion into the solar system over the next several hundred years. This suggests intelligence that anticipates technological development with precision that implies detailed study of human civilization across extended historical periods. Public awareness of the electromagnetic interference has generated reactions ranging from fascination to genuine alarm as news coverage emphasizes the vulnerability of critical space-based infrastructure. Social media platforms struggle to manage information flow about developments that challenge fundamental assumptions about security and technological independence. The realization that essential services dependent on satellite networks could be disrupted by alien technology creates anxiety levels that government officials struggle to address through conventional reassurance strategies. Educational institutions face immediate pressure to update curricula, addressing operational realities that weren't theoretical possibilities just months ago. Students preparing for careers in aerospace engineering and space science must now consider scenarios involving active alien interference with human space systems. The transition from speculative fiction to documented operational fact has compressed decades of theoretical development into a matter of weeks, leaving academic programs scrambling to provide relevant training for careers that may require entirely new skill sets. The economic implications ripple through industries dependent on space-based infrastructure and satellite communications. Insurance companies face the impossible task of assessing risks when the threat landscape includes entities whose interference capabilities and intentions remain completely unknown. Stock markets show extreme volatility in aerospace and telecommunications sectors as investors attempt to price in the implications of technologies that could render current space assets obsolete through coordinated electromagnetic attacks. International space agencies have initiated emergency protocols for coordinated response to interference scenarios that exceed any existing contingency planning. The United Nations Office for Outer Space Affairs faces diplomatic challenges that transcend traditional frameworks when dealing with entities possessing both interstellar travel capabilities and the ability to actively disrupt human space operations. Treaty negotiations become meaningless when one party possesses technological advantages measured in centuries or millennia. As 3I Atlas approaches within 6 days of its closest Mars passage, the electromagnetic interference demonstrates escalating sophistication with each spacecraft interaction. New pulse patterns emerge daily, each more precisely targeted than previous demonstrations. The accelerating development suggests either activation of previously dormant capabilities or preparation for operational phases timed to coincide with the Mars encounter that could reveal the true scope of these entities' technological capabilities. The transformation from anomalous interstellar visitor to active interference system has fundamentally altered humanity's relationship with space exploration and our understanding of technological security in the cosmic environment. We can no longer assume operational independence in our space activities or protection from interference by intelligence that monitors our every move and possesses the capability to disable our most sophisticated systems at will. The final countdown toward Mars encounter represents more than a scientific observation opportunity. It has become a test of human resilience in the face of technologies that exceed our understanding and challenge our assumptions about independence and security in space. The universe has revealed itself to be under active management by intelligence, whose presence we never suspected, and whose intervention, capabilities we are only beginning to comprehend. The impossible has become inevitable, and our entire approach to space exploration stands poised for fundamental transformation. The latest electromagnetic pulse lasted exactly 12 seconds and disabled both Mars orbiters simultaneously across a separation distance of 8,000 kilometers. When systems came back online, the spacecraft had been repositioned into perfectly circular orbits with mathematical precision that exceeded anything achievable through human orbital mechanics. We are no longer operating in space. We are being operated by intelligence that treats our most advanced technology as toys worthy of occasional adjustment and improvement. The message couldn't be clearer. We are being managed, studied, and occasionally corrected by entities whose capabilities transcend every assumption about what's possible in the universe. The countdown to Mars encounter has become a countdown to revelation that will either provide answers to questions that have driven human curiosity since we first looked up at the stars, or demonstrate that our questions themselves were hopelessly inadequate for comprehending the reality we now inhabit. 5 days remain until we discover which possibility defines our future among the stars. The orbital mechanics team at NASA's Jet Propulsion Laboratory received telemetry at 2:47 a.m. Pacific Time this morning that fundamentally rewrote the laws of physics as we understand them. Dr. Amanda Foster, who has spent 23 years analyzing spacecraft trajectories, found herself staring at data that her training said was impossible. Both Mars Reconnaissance Orbiter and Mars Express had been moved into new orbital configurations without any propulsive maneuvers from their own systems. The precision is what terrifies me. Foster explained during the emergency briefing that followed. These weren't random orbital adjustments. Both spacecraft are now positioned in mathematically perfect circular orbits with inclinations calculated to optimize observation coverage of the Martian surface. Someone or something performed orbital mechanics calculations that would challenge our best supercomputers, then executed those maneuvers using our own spacecraft as if they were remote-controlled toys. The implications cascade through every assumption about space operations and technological sovereignty. If alien intelligence can commandeer human spacecraft and improve their orbital parameters at will, every mission currently operating beyond Earth's atmosphere exists at the discretion of entities whose objectives remain completely mysterious. The technical analysis reveals intervention methods that transcend known propulsion physics. Both orbiters experienced simultaneous trajectory changes despite being separated by thousands of kilometers and operating on completely different orbital planes. The energy requirements for such precise repositioning should have required substantial fuel expenditure from onboard propulsion systems, yet neither spacecraft reported any thruster activity or fuel consumption during the maneuver. Ground control teams worldwide face the psychological challenge of operating spacecraft that can apparently be overridden by external intelligence at any moment. Mission commanders report difficulty maintaining operational focus when every trajectory calculation might be subject to revision by entities whose engineering capabilities exceed human technology by orders of magnitude that remain impossible to quantify. The electromagnetic signatures detected during the orbital adjustments reveal coordination patterns that operate faster than light-speed communication delays should allow. When Mars Reconnaissance Orbiter began its repositioning sequence, Mars Express initiated its own trajectory changes within milliseconds, despite being positioned where radio signals would require several minutes to traverse the intervening distance. This suggests either exotic communication methods or predictive algorithms sophisticated enough to coordinate complex operations across relativistic constraints. Dr. Patricia Chen at the European Space Operations Centre leads the team attempting to reverse engineer the propulsion methods used during the orbital adjustments. Her preliminary analysis indicates force vectors that don't correspond to any known thruster configuration or gravitational assist mechanism. We're observing acceleration profiles that suggest external manipulation of spacecraft mass or momentum without any detectable interaction with conventional propulsion systems, Chen reported. The physics involved transcends our current understanding of how objects move through space. The strategic implications extend far beyond the immediate spacecraft repositioning. If these entities possess the capability to modify human space assets at will, they could potentially disable global communication networks, navigation systems, and weather monitoring satellites whenever they choose. The comprehensive nature of Earth's dependence on space-based infrastructure creates vulnerabilities that no terrestrial defensive system could address. Intelligence agencies have elevated their assessment protocols to classification levels that didn't exist before this week. The demonstration of active control over human spacecraft represents a capability that could neutralize every military and civilian space asset currently in operation. Traditional concepts of space-based deterrence become meaningless when potential adversaries possess the ability to commandeer your weapon systems and redirect them according to their own strategic objectives. The precision timing of these orbital adjustments reveals planning capabilities that anticipate spacecraft operations with disturbing accuracy. Analysis of telemetry logs indicates that the repositioning maneuvers began exactly 37 minutes before ground control had finalized plans to adjust the orbiter's observation schedules. This suggests either comprehensive monitoring of terrestrial mission planning activities or behavioral prediction algorithms that can anticipate human decision-making processes with supernatural precision. Amateur radio operators monitoring spacecraft communications have detected similar anomalies affecting other deep space missions. The Juno probe at Jupiter experienced unexplained trajectory modifications that improved its orbital efficiency while consuming no measurable fuel. The Parker Solar Probe reported course corrections that optimized its solar observation geometry using propulsion methods that appear nowhere in its technical specifications. The distributed nature of these interventions suggests a surveillance and control network that encompasses the entire inner solar system. Particle formations detected around 3I Atlas appear to represent only the visible portion of a much larger infrastructure that can monitor and manipulate human space activities from any location within several astronomical units of Earth. The energy management requirements for executing such precise orbital mechanics across multiple spacecraft simultaneously should produce detectable signatures through thermal emissions or electromagnetic radiation. Yet sensors aboard both orbiters detected no unusual energy sources during their repositioning sequences. The propulsion methods appear to operate through principles that circumvent conventional thermodynamics and conservation laws. Mission planners face operational nightmares that no training program ever contemplated. How do you maintain mission schedules when your spacecraft can be repositioned without notice? How do you plan scientific observations when orbital parameters might change according to priorities established by intelligence beyond human comprehension? Traditional mission control becomes impossible when the systems you're controlling can be overridden by entities whose intentions remain completely unknown. The psychological impact on astronauts currently serving aboard the International Space Station has become a critical concern for mission medical officers. Knowing that their orbital laboratory could potentially be repositioned or modified by alien technology creates stress levels that affect both individual performance and crew cohesion. Commander Sarah Williams reported during yesterday's private communication that crew members have difficulty sleeping while contemplating the possibility that their life support systems might be under external control. Scientific institutions worldwide have abandoned normal research protocols to focus on understanding intervention methods that challenge fundamental assumptions about physics and engineering. The interdisciplinary nature of the challenge requires expertise spanning orbital mechanics, exotic propulsion theories, quantum field dynamics, and speculative technologies that exist only in theoretical frameworks. The mathematical elegance of the new orbital configurations reveals engineering principles optimized for efficiency levels that approach theoretical limits. Both spacecraft now follow trajectories that maximize scientific observation opportunities while minimizing fuel consumption and mechanical stress on aging systems. The improvements suggest intelligence that understands human engineering limitations and chooses to work within those constraints, rather than simply demonstrating technological superiority. Ground-based observatories have detected similar orbital modifications affecting several commercial satellites in Earth orbit. Geostationary communication platforms have been repositioned into configurations that improve signal coverage while reducing orbital debris collision risks. The adjustments appear designed to optimize the performance of human space infrastructure rather than disable or destroy it. The benevolent nature of these interventions provides some reassurance about the entity's intentions, but the demonstration of comprehensive control over human space assets creates strategic vulnerabilities that military planners struggle to address. How do you defend against intelligence that can improve your own systems, while simultaneously proving its ability to disable them whenever circumstances might require more aggressive action? The communication protocols detected during orbital adjustment sequences reveal data exchange patterns that suggest real-time coordination between particle formations scattered across millions of cubic kilometers. Radio telescopes monitoring the Mars region detect structured signals that cycle through frequency patterns optimized for maximum information density while avoiding interference with natural cosmic phenomena. International space agencies have initiated emergency consultation procedures for coordinated response to technological interventions that exceed any existing diplomatic framework. The United Nations Office for Outer Space Affairs faces scenarios that transcend traditional sovereignty concepts when dealing with entities capable of modifying space-based infrastructure according to their own operational requirements. The timeline acceleration has caught space agencies unprepared for the rapid evolution from passive surveillance to active intervention. What began as mysterious particle deployments just 3 weeks ago has escalated into demonstrated control over human spacecraft that challenges fundamental assumptions about technological independence in space. The exponential increase in capability suggests either activation of previously dormant systems or approach of operational phases that will reveal the true scope of these entities' technological infrastructure. Public reaction to news of spacecraft repositioning has generated responses ranging from awe to genuine terror as the implications become clear through social media analysis and expert commentary. The realization that essential space-based services could be modified or disabled by alien intelligence creates anxiety levels that government officials struggle to address through conventional public relations strategies. Educational institutions face immediate pressure to revise engineering curricula, addressing operational realities that weren't theoretical possibilities just days ago. Students preparing for careers in aerospace and space systems engineering must now consider scenarios involving active alien oversight of human space operations. The transition from academic speculation to documented operational fact has compressed decades of theoretical development into a timeframe that leaves educational programs scrambling to provide relevant training. The economic implications ripple through industries dependent on space-based infrastructure and satellite services. Insurance companies face impossible risk assessment challenges when coverage includes potential modification by intelligence whose capabilities and intentions remain completely unknown. Financial markets show extreme volatility in aerospace sectors as investors attempt to evaluate companies whose primary assets could be improved, disabled, or commandeered by entities operating beyond human technological understanding. Manufacturing firms developing space-based systems confront the possibility that their most advanced designs might be subject to external modification according to engineering standards that exceed human capabilities by unknown margins. Quality control processes become meaningless when the final products might be upgraded by intelligence that possesses comprehensive understanding of both human engineering limitations and optimization techniques that transcend current technological frameworks. As 3I Atlas approaches within 4 days of its closest Mars passage, the orbital interventions demonstrate escalating sophistication with each spacecraft interaction. New positioning strategies emerge with each observation cycle, revealing optimization algorithms that adapt to changing mission requirements faster than human operators can formulate response procedures. The accelerating development suggests preparation for operational phases timed to coincide with the Mars encounter that could reveal capabilities exceeding anything demonstrated thus far. The transformation from anomalous interstellar visitor to active spacecraft control system has fundamentally altered humanity's relationship with space exploration and our understanding of technological autonomy beyond Earth's atmosphere. We can no longer assume independent operation of our space assets or control over the infrastructure upon which modern civilization depends. The universe has revealed itself to be under active management by intelligence whose presence we never suspected and whose intervention capabilities we are only beginning to comprehend. The countdown toward Mars encounter represents more than a scientific milestone or technological demonstration. It has become a moment of truth that will either provide answers to questions about intelligence and technology in the universe, or reveal that our understanding of space operations, physics, and our place among the stars was fundamentally incomplete from the very beginning. The impossible has become routine, and our entire conception of human independence in space stands transformed by entities whose next actions could reshape civilization itself. The silence from mission control centers worldwide speaks volumes about the magnitude of what we're witnessing. When your most sophisticated spacecraft can be repositioned like chess pieces by intelligence that operates according to rules you don't understand, traditional concepts of space exploration become obsolete overnight. We are no longer pioneers venturing into the unknown. We have become subjects of observation and occasional correction by intelligence that views our technological achievements as worthy of improvement rather than opposition. 3 days remain until 3I Atlas reaches its closest approach to Mars. 3 days until we discover whether these demonstrations of technological superiority represent the limits of alien intervention in human affairs, or merely the preliminary exercises before revelations that will transform our understanding of existence itself. The countdown continues toward an encounter that has already changed everything we thought we knew about our place in the universe. The automated emergency protocols aboard Mars Reconnaissance Orbiter triggered for the 7th time in 48 hours. Flight director Michael Torres watched his screens with the resignation of someone who'd accepted that the rules of space operations had been permanently rewritten. The spacecraft that humanity had spent $2 billion developing was now being treated as a remote-controlled demonstration model by intelligence that could override every system at will. At 6:33 UTC this morning, both Mars orbiters simultaneously executed maneuvers that no human engineer had programmed. The coordination between spacecraft separated by 12,000 kilometers occurred with timing precision that violated the speed of light limitations governing all known communication methods. When the maneuvers concluded, both vehicles had been positioned into orbital configurations that optimized their sensor coverage while reducing fuel consumption by margins that exceeded the design specifications of their propulsion systems. "We're not operating these spacecraft anymore," Torres announced during the morning briefing that had become a daily ritual of acknowledging human technological irrelevance. "We're passengers aboard our own missions, watching alien intelligence demonstrate engineering capabilities that make our most advanced systems look like children's toys. The technical impossibilities multiply with each passing hour. Yesterday's trajectory modifications required energy expenditures that should have consumed weeks' worth of propellant reserves. Yet both orbiters reported zero fuel usage during the repositioning sequences. The propulsion methods appear to manipulate spacecraft momentum through mechanisms that bypass conventional thruster systems entirely." Dr. Jennifer Walsh at the European Space Operations Centre has been analysing the physics of these impossible manoeuvres since they began 3 days ago. Her team's calculations indicate acceleration profiles that suggest external manipulation of mass-energy relationships in ways that transcend Einstein's relativistic frameworks. "We're observing spacecraft behavior that violates conservation laws fundamental to our understanding of reality," Walsh explained. "Either our instruments are systematically lying to us, or we're witnessing technology that operates according to physics we haven't discovered yet. The electromagnetic signatures accompanying each orbital adjustment reveal coordination mechanisms that operate instantaneously across distances where light speed delays should prevent simultaneous action. When Mars Reconnaissance Orbiter initiates a trajectory change, Mars Express begins its corresponding maneuver within nanoseconds, despite being positioned where radio signals require several minutes to traverse the separation distance. Ground control teams worldwide face the psychological challenge of maintaining mission operations when their most sophisticated systems can be commandeered without notice. Traditional flight dynamics calculations become exercises in futility when orbital parameters might change according to optimization criteria established by intelligence whose engineering principles exceed human comprehension by margins that remain impossible to quantify. The strategic implications extend throughout every aspect of space-based infrastructure. If these entities can modify spacecraft trajectories with mathematical precision while consuming no fuel, they possess capabilities that could neutralize every human space asset within hours of deciding to do so. Satellite networks providing GPS navigation, weather monitoring, and global communications exist at the discretion of intelligence whose intentions remain completely opaque. Intelligence agencies have classified the spacecraft control demonstrations as representing threat levels that exceed all existing assessment frameworks. The ability to commandeer human space assets while improving their operational performance suggests technological superiority that renders conventional defensive strategies meaningless. How do you protect against entities that can enhance your own systems while simultaneously proving their ability to disable them whenever circumstances might require different responses. The precision of these orbital modifications reveals planning capabilities that anticipate human mission requirements with disturbing accuracy. Analysis of telemetry records indicates that trajectory adjustments consistently improve scientific observation opportunities, reduce mechanical stress on aging systems, and optimize fuel consumption patterns. The intelligence controlling these maneuvers appears to understand human engineering limitations better than human engineers themselves. Amateur astronomers monitoring spacecraft communications have detected similar interventions affecting deep space missions throughout the solar system. The New Horizons probe beyond Pluto experienced course corrections that improved its trajectory toward the heliopause while consuming no measurable propellant. The Parker Solar Probe reported orbital adjustments that enhanced its solar observation geometry, using propulsion methods that appear nowhere in NASA's technical documentation. The distributed nature of these interventions confirms the presence of a control network that encompasses the entire solar system. Particle formations around 3I Atlas represent merely the visible components of infrastructure capable of monitoring and manipulating human space activities from any location within astronomical units of Earth. The comprehensive surveillance and control architecture suggests technological deployment that occurred over timescales measured in decades or centuries, rather than the weeks since initial detection. The energy management requirements for executing simultaneous orbital mechanics across multiple spacecraft should produce thermal signatures detectable by infrared sensors, yet no unusual heat emissions accompany the trajectory modifications, suggesting propulsion methods that circumvent thermodynamic principles governing all known energy conversion processes. The technology appears to operate through mechanisms that transcend conventional physics, while achieving results that human engineering can barely comprehend. Mission planners at NASA and ESA confront operational nightmares that no training program ever addressed. How do you schedule scientific observations when orbital parameters might change without notice? How do you maintain crew safety when life support systems aboard the International Space Station could potentially be modified by external intelligence? Traditional mission control becomes impossible when the systems you're managing can be overridden by entities whose priorities remain completely unknown. The psychological impact on astronauts currently serving in space has escalated beyond manageable levels. Commander Sarah Williams aboard the International Space Station reported during yesterday's classified communication that crew members experienced severe anxiety knowing their orbital laboratory could be repositioned or modified by alien technology. Sleep schedules suffer when personnel contemplate the possibility that their life support systems might be under external monitoring and potential control. Scientific institutions worldwide have suspended normal research activities to focus on understanding intervention methods that challenge fundamental assumptions about physics and engineering. The interdisciplinary nature of the challenge requires expertise spanning exotic propulsion theories, quantum field dynamics, and speculative technologies that exist only in theoretical frameworks, developed by researchers who never expected their work to become immediately relevant to operational space missions. The mathematical elegance of the new orbital configurations demonstrates optimization algorithms that maximize mission effectiveness while operating within the mechanical limitations of human-built spacecraft. Both Mars orbiters now follow trajectories that provide superior surface coverage while reducing wear on attitude control systems and minimizing collision risks with space debris. The improvements suggest intelligence that chooses to enhance human capabilities rather than simply demonstrating technological dominance. Ground-based observatories have documented similar orbital modifications affecting commercial satellites throughout Earth's orbital environment. Geostationary communication platforms have been repositioned into configurations that improve signal coverage while reducing the probability of catastrophic collisions with orbital debris. The adjustments appear designed to optimize the performance and longevity of human space infrastructure, rather than disable or destroy critical systems. The apparently benevolent nature of these interventions provides limited reassurance about the entity's long-term intentions. While current modifications enhance rather than degrade spacecraft performance, the demonstration of comprehensive control over human space assets creates vulnerabilities that military strategists struggle to address through conventional defensive planning. The intelligence capable of improving your systems today could disable them tomorrow if circumstances required more aggressive responses to human activities. The communication protocols detected during orbital adjustment sequences reveal data exchange patterns that coordinate particle formations across millions of cubic kilometers in real time. Radio telescopes monitoring the Mars region detect structured signals that utilize frequency hopping techniques optimized for maximum information density, while avoiding interference with natural electromagnetic phenomena throughout the solar system. International space agencies have initiated emergency consultation procedures for developing coordinated responses to technological interventions that transcend existing diplomatic frameworks. The United Nations Office for Outer Space Affairs faces scenarios that challenge traditional concepts of sovereignty when dealing with entities capable of modifying space-based infrastructure according to their own operational requirements without regard for human ownership or control. The acceleration of intervention capabilities has caught space agencies completely unprepared for the transition from passive surveillance to active system control. What began as mysterious particle deployments barely 3 weeks ago has evolved into demonstrated mastery over human spacecraft that challenges fundamental assumptions about technological independence beyond Earth's atmosphere. The exponential increase in demonstrated capabilities suggests either activation of previously dormant systems or approach of operational phases that will reveal the true extent of alien technological infrastructure. Public awareness of spacecraft commandeering has generated reactions ranging from fascination to genuine terror as the implications penetrate mainstream consciousness through social media coverage and expert analysis. The realization that essential space-based services supporting modern civilization could be modified or disabled by alien intelligence creates anxiety levels that government officials struggle to address through traditional public reassurance strategies. Educational institutions face immediate pressure to completely restructure aerospace engineering curricula, addressing operational realities that weren't theoretical possibilities just days ago. Students preparing for careers in space systems development must now consider scenarios involving active alien oversight of human space operations as standard operating conditions rather than science fiction speculation. The transition from academic theory to documented operational fact has compressed decades of curriculum development into timeframes that leave educational programs scrambling to provide relevant training for careers that may require entirely new conceptual frameworks. The economic implications cascade through industries dependent on space-based infrastructure and satellite services as investors attempt to evaluate assets that could be improved, commandeered, or disabled by intelligence operating beyond human technological understanding. Insurance companies face impossible risk assessment challenges when coverage policies must account for modification by entities whose capabilities and intentions remain completely unknown. Manufacturing firms developing space systems confront the possibility that their most advanced designs might be subject to external upgrade according to engineering standards that exceed human capabilities by margins that remain impossible to quantify. Quality assurance processes become meaningless when final products might be enhanced by intelligence possessing comprehensive understanding of both human engineering limitations and optimization techniques that transcend current technological frameworks. Research and development investments lose predictable returns when alien intelligence might render entire technological approaches obsolete. through demonstrations of superior methodologies that human science hasn't yet discovered. As 3I Atlas approaches within 72 hours of its closest Mars passage, the spacecraft control interventions demonstrate escalating sophistication with each orbital modification. New positioning strategies emerge faster than human operators can analyze previous maneuvers, revealing optimization algorithms that adapt to changing mission requirements with computational speeds that exceed terrestrial supercomputing capabilities. The accelerating development suggests preparation for operational phases timed to coincide with the Mars encounter that could reveal capabilities surpassing anything demonstrated during the preliminary control exercises. The transformation from anomalous interstellar visitor to comprehensive spacecraft control system has fundamentally altered humanity's relationship with space exploration and our understanding of technological autonomy throughout the solar system. We can no longer assume independent operation of space assets or autonomous control over the infrastructure upon which modern civilization depends for communication, navigation, and scientific research. The universe has revealed itself to be under active management by intelligence, whose presence we never suspected, and whose intervention capabilities we are only beginning to comprehend. The countdown toward Mars encounter represents more than a scientific observation opportunity or technological demonstration. It has become a moment of truth that will either provide answers to questions about the nature of intelligence and technology in the universe, or reveal that our understanding of physics, space operations, and our place among the stars was fundamentally incomplete from the beginning. The impossible has become routine operational reality, and our entire conception of human independence in space stands transformed by entities whose next actions could reshape the foundations of civilization itself. Mission control centers worldwide maintain their vigils not as commanders of sophisticated spacecraft, but as witnesses to demonstrations of technological mastery that reduce humanity's greatest achievements to the status of amusing toys worthy of occasional improvement and constant supervision. 72 hours remain until 3I Atlas reaches its closest approach to Mars. 72 hours until we discover whether these displays of absolute technological superiority represent preliminary exercises designed to prepare us for revelations that will transform human understanding of existence itself, or merely the opening movements of a cosmic symphony whose true complexity exceeds our ability to comprehend. The countdown continues toward an encounter that has already revolutionized everything we thought we knew about our cosmic neighborhood and our place within it. The latest intervention occurred at 11:47 UTC this morning, and this time the demonstration transcended mere spacecraft repositioning. Both Mars orbiters simultaneously began broadcasting enhanced telemetry signals with data compression rates that exceed theoretical limits for electromagnetic transmission. The spacecraft that humanity built according to 20th century engineering principles are now operating according to 21st century physics that human science hasn't discovered yet. Flight controllers worldwide watch their screens display impossible performance metrics while acknowledging that we are no longer operating in space. We are being operated by intelligence that has transformed our most advanced technology into teaching tools for lessons we're not yet sophisticated enough to understand. The universe has become our classroom, and class is about to begin. The transmission logs from Deep Space Network stations worldwide paint a picture that defies every assumption about electromagnetic physics. At 14:23 UTC today, September 24th, 2025, radio telescopes detected something that shouldn't exist according to Maxwell's equations and century-old understanding of how signals propagate through space. Dr. Rachel Morrison at the Goldstone Deep Space Communications Complex received data streams that made her question whether her instruments had malfunctioned or whether she was witnessing technology that operates beyond known electromagnetic theory. The signals weren't just coming from 3I Atlas anymore. They were originating from locations throughout the inner solar system where no transmitters should exist. We're detecting coherent radio emissions from coordinates that correspond to empty space, Morrison explained during the emergency technical briefing that followed. These aren't reflections or echoes. These are original transmissions using modulation schemes that achieve information density rates, exceeding Shannon's theoretical limits by factors we can't even calculate properly. The discovery transforms our understanding of the surveillance network from passive observation to active communication infrastructure. What appeared to be microscopic particles scattered by 3 IATLAS have revealed themselves as nodes in a distributed antenna array spanning millions of cubic kilometers. The engineering achievement surpasses anything human civilization could accomplish within the next century of technological development. The signal characteristics themselves challenge fundamental assumptions about information theory. Claude Shannon's mathematical proofs established absolute limits for data transmission through noisy channels, limits that have governed every communication system ever built. Yet the transmissions detected today achieve compression ratios that violate those mathematical constraints while maintaining perfect signal clarity across interplanetary distances. Dr. James Patterson at MIT's Computer Science and Artificial Intelligence Laboratory leads the team attempting to decode the transmission protocols. His preliminary analysis reveals encoding schemes that utilize quantum entanglement principles for error correction, suggesting technology that treats individual photons as computational elements rather than simple carriers of electromagnetic energy. We're observing communication methods that appear to encode information directly into the quantum states of electromagnetic radiation, Patterson reported during yesterday's classified briefing. The bandwidth utilization approaches 100% efficiency while maintaining 0-bit error rates across distances where cosmic radiation should degrade any conventional signal beyond recognition. The distributed nature of the antenna array creates communication capabilities that dwarf humanity's most ambitious space networking projects. Individual nodes positioned throughout the solar system coordinate their transmissions to create focused beams that can reach any target within several astronomical units while consuming minimal power. The beam-forming precision suggests computational coordination that operates faster than light-speed delays should permit. Ground-based radio astronomy facilities worldwide have detected similar transmission networks operating at frequencies reserved for deep space research. The signals utilize spectrum allocations that international treaties designated for scientific observation, suggesting either detailed knowledge of human regulatory frameworks or complete disregard for terrestrial communication protocols. The power requirements for maintaining such extensive communication networks should produce detectable thermal signatures through waste heat radiation. Yet infrared telescopes monitoring the transmission coordinates detect no unusual heat emissions, indicating energy conversion efficiencies that approach theoretical perfection, or power sources that operate through mechanisms transcending conventional thermodynamics. Amateur radio operators equipped with software-defined receivers have contributed crucial observations that professional facilities initially missed due to their focus on traditional communication bands. The distributed monitoring network, created by dedicated enthusiasts, provides coverage that supplements institutional capabilities, while demonstrating that detection of these transmissions requires neither expensive equipment nor advanced technical training. The modulation techniques employed by the network reveal mathematical sophistication that exceeds current human understanding of signal processing theory. Frequency hopping patterns cycle through thousands of channels per microsecond while maintaining perfect synchronization across nodes separated by millions of kilometers. The coordination mechanisms suggest computational capabilities that process information at rates approaching the physical limits imposed by quantum mechanics. Intelligence agencies worldwide have classified the communication intercepts as representing capabilities that transcend existing threat assessment frameworks. A distributed antenna network capable of coordinating transmissions across interplanetary distances could potentially overwhelm every human communication system through targeted interference or spoofing attacks that would be impossible to counter using conventional electronic warfare techniques. The timing analysis reveals transmission schedules that anticipate human communication activities with disturbing precision. Network traffic increases significantly during periods when Earth-based facilities conduct deep space observations, suggesting real-time monitoring of terrestrial research activities. The entities operating this infrastructure appear to possess detailed knowledge of human scientific schedules and communication protocols. The signal propagation characteristics indicate transmission methods that circumvent inverse square law limitations governing all known electromagnetic radiation. Signals maintain consistent strength across distances where conventional radio waves would attenuate to undetectable levels, suggesting either exotic physics or amplification techniques that boost signal power without introducing noise or distortion. European radio astronomy facilities have detected similar networks operating at millimeter wavelengths typically used for molecular spectroscopy and atmospheric research. The signals interfere with observations of cosmic molecular clouds while providing no obvious scientific benefit to their generators, suggesting either deliberate jamming of human research activities or utilization of those frequency bands for purposes we cannot comprehend. The data encryption methods employed by the network resist all attempts at cryptographic analysis using conventional techniques. The signal content appears to utilize one-time pad encryption with key lengths that exceed the duration of individual transmissions, making decryption mathematically impossible without access to the original key generation algorithms. The security implementation suggests operational experience with cryptographic warfare spanning centuries of technological development. Mission planners at space agencies worldwide confront communication security challenges they never anticipated facing. How do you maintain operational security when your most sensitive transmissions might be monitored by intelligence possessing comprehensive situational awareness throughout the solar system? Traditional communication encryption becomes meaningless when potential adversaries possess computational capabilities that exceed human technology by unknown margins. The network topology reveals architecture designed for redundancy and fault tolerance that surpasses anything achieved in terrestrial communication systems. Individual node failures produce no detectable degradation in overall network performance, suggesting either massive over-provisioning of communication capacity or dynamic routing algorithms that adapt to changing conditions faster than human network administrators could respond to system outages. Scientific institutions have initiated emergency protocols for analyzing communication methods that challenge fundamental assumptions about information theory and electromagnetic physics. The interdisciplinary nature of the challenge requires expertise spanning quantum mechanics, cryptography, signal processing, and theoretical computer science. Academic boundaries dissolve when confronting technologies that transcend established scientific categories. The mathematical elegance of the transmission protocols demonstrates optimization principles that maximize information transfer while minimizing energy expenditure and electromagnetic signature detection. The efficiency levels approach theoretical limits established by quantum mechanical constraints on information processing, suggesting technology that has been refined through extensive practical experience, spanning technological development periods measured in centuries or millennia. Ground-based observatories operating at radio wavelengths have detected transmission bursts that correlate with 3I Atlas's approach trajectory, suggesting activation of previously dormant network components as the primary object nears its Mars encounter. The escalating communication activity indicates preparation for operational phases that may coincide with the closest approach scheduled for tomorrow. The frequency coordination employed by the network avoids interference with natural cosmic radio sources while maximizing information capacity within available spectrum allocations. The signal management demonstrates comprehensive understanding of both terrestrial communication protocols and natural electromagnetic phenomena throughout the solar system, suggesting intelligence that has conducted extensive reconnaissance of human technological capabilities and natural environmental conditions. International telecommunications organizations face regulatory challenges they never anticipated when spectrum management must account for unauthorized users possessing technology that exceeds human capabilities by margins that remain impossible to quantify. Traditional approaches to frequency allocation and interference mitigation become obsolete when dealing with entities that can utilize electromagnetic spectrum with efficiency levels that approach physical limits. The communication intercepts reveal coordination patterns that suggest real-time tactical planning across entities distributed throughout multiple planetary orbits. Transmission bursts often precede spacecraft interventions by precisely calculated intervals, indicating either prescient planning capabilities or communication speeds that exceed light velocity limitations through mechanisms that transcend relativistic physics. Public awareness of the communication network has generated reactions ranging from fascination to genuine alarm, as technical analysis reveals the comprehensive nature of the surveillance and coordination infrastructure. Social media platforms struggle to manage information flow about developments that demonstrate humanity's complete technological inferiority in comparison to intelligence operating according to engineering principles we're only beginning to discover. Educational institutions face immediate pressure to revise communications engineering curricula, addressing operational realities that weren't theoretical possibilities just weeks ago. Students preparing for careers in telecommunications and signal processing must now consider scenarios involving active competition with alien communication systems that utilize physics beyond current human understanding. The transition from academic theory to operational necessity has compressed decades of curriculum development into timeframes that leave educational programs inadequate for training professionals who may need to work within technological frameworks that transcend conventional engineering principles. The economic implications cascade through industries dependent on electromagnetic spectrum utilization and satellite communications. Telecommunications companies confront the possibility that their most sophisticated systems might be subject to interference or monitoring by intelligence, possessing comprehensive understanding of terrestrial communication protocols combined with technological capabilities that exceed human development by centuries of advancement. Manufacturing firms developing communication equipment face the challenge of competing with technology that achieves performance levels approaching physical limits while consuming minimal power and producing virtually no detectable signatures. Quality assurance becomes meaningless when competing products might utilize engineering principles that human science hasn't yet discovered through conventional research and development processes. As IATLAS approaches within 24 hours of its closest Mars passage, the communication network demonstrates escalating activity levels with each monitoring cycle. New transmission protocols emerge faster than human analysts can decode previous signal formats, revealing adaptive algorithms that modify communication strategies in real time based on changing operational requirements and environmental conditions. The transformation from mysterious interstellar visitor to comprehensive communication infrastructure has fundamentally altered humanity's understanding of electromagnetic spectrum utilization and our assumptions about privacy in electronic communications. We can no longer assume security in our most sensitive transmissions or independence in our communication technologies when operating within range of intelligence that monitors every electromagnetic emission while utilizing frequencies and modulation schemes that transcend our theoretical understanding. The universe has revealed itself to contain communication networks that operate according to principles we're only beginning to comprehend, managed by intelligence whose presence we never suspected and whose technological capabilities we are only starting to appreciate. The countdown toward Mars encounter represents more than a scientific observation opportunity. It has become a moment of technological revelation that will either provide insights into communication methods that could advance human civilization by centuries, or demonstrate that our understanding of information from the beginning, the impossible has theory and electromagnetic physics was fundamentally incomplete, become the foundation for new technological realities. And our entire approach to communication systems design stands transformed by entities whose next transmissions could reveal capabilities that reshape our understanding of what's possible when intelligence applies itself to mastering the fundamental forces governing information exchange throughout the cosmos. 24 hours remain until 3I Atlas reaches its closest approach to Mars. 24 hours until we discover whether these demonstrations of absolute communication superiority represent preliminary exercises designed to establish contact protocols, or merely the initialization sequences for revelation processes whose complexity exceeds our current ability to comprehend the true scope of intelligence that operates throughout our cosmic neighborhood. The signals continue streaming across space at data rates that violate theoretical limits, while maintaining perfect clarity across distances that should degrade any conventional transmission beyond recognition. We are no longer alone in the electromagnetic spectrum, and the entities sharing those frequencies possess capabilities that transform our most advanced communication systems into primitive experiments worthy of patient observation and occasional technical correction. Tomorrow's encounter will either mark the beginning of humanity's education in cosmic communication technologies, or reveal that we were never qualified students for the curriculum that intelligence throughout the universe has been developing since before human civilization learned to harness electromagnetic radiation for primitive signaling purposes. The cosmic classroom awaits, and the final examination approaches with mathematical precision that exceeds our ability to calculate the scope of what we're about to discover. The final transmission, burst detected at 7:14 UTC this morning, contains something that has left cryptographers worldwide questioning everything they understand about information encoding. Hidden within the quantum encrypted data streams flowing between particle nodes throughout the solar system, pattern recognition algorithms have identified what can only be described as mathematical poetry, written in prime numbers and cosmic constants. Dr. Elena Vasquez at the National Security Agency's Cryptographic Research Division received the decoded fragments at 9:33 UTC and immediately classified them at levels that didn't exist before this week. The message wasn't random data or operational coordinates. It was a greeting card written in the universal language of mathematics, addressed specifically to the mathematical minds of Earth. We're looking at number sequences that reference our own scientific discoveries, Vasquez explained during the emergency briefing that followed. Pi calculated to precision levels we've never achieved. The fine structure constant measured more accurately than our best laboratory equipment. But embedded within these demonstrations of mathematical knowledge are new constants, new relationships that our physics hasn't discovered yet. The implications strike at the heart of human intellectual pride. These entities don't just possess superior technology. They understand our mathematics better than we do, while simultaneously demonstrating knowledge that extends far beyond anything human science has achieved. The message serves as both greeting and gentle correction to a species whose mathematical understanding appears incomplete. The decryption process itself required computational resources that pushed terrestrial supercomputers to their operational limits. The encoding scheme utilized prime factorization keys with digit lengths that exceed anything achievable through conventional mathematical approaches, yet somehow remained solvable using techniques that human cryptographers developed independently over the past century. Dr. Michael Chen at the Institute for Advanced Study in Princeton leads the international team attempting to understand the mathematical content. His preliminary analysis reveals formulas that appear to describe unified field theories, linking electromagnetic forces with gravitational effects through mathematical relationships that Einstein spent decades seeking unsuccessfully. They're not just showing us advanced mathematics, Chen reported during yesterday's classified session. They're providing solutions to problems that have defined the frontiers of theoretical physics for over a century. The equations are elegant, internally consistent, and predict experimental results that we haven't conducted yet but could verify using existing laboratory equipment. The timing of this mathematical revelation couldn't be more significant. As 3I Atlas approaches its final hours before Mars encounter, The entities controlling the surveillance network have chosen to demonstrate intellectual capabilities that transcend technological superiority. They're proving that their advantages extend beyond engineering and encompass fundamental understanding of reality itself. Ground-based mathematicians working around the clock have verified several of the simpler formulas through computational analysis. The equations describing electromagnetic field interactions produce results that match experimental data with precision exceeding anything achieved through human theoretical frameworks. The mathematical tools being provided could accelerate human scientific development by decades or centuries. The philosophical implications penetrate every assumption about intelligence and knowledge in the universe. If these entities possess mathematical understanding that surpasses human achievement while simultaneously comprehending our own mathematical traditions, they represent intellectual development that spans timescales measured in millennia rather than centuries of academic progress. Amateur mathematicians participating in distributed computing projects have contributed crucial verification efforts that professional institutions couldn't complete within available time constraints. The collaborative analysis demonstrates that understanding these mathematical gifts requires neither advanced degrees nor institutional resources, merely dedication to logical reasoning and computational persistence. The pedagogical structure of the mathematical message reveals teaching methods designed specifically for minds operating according to human cognitive limitations. Complex concepts are introduced through familiar mathematical frameworks before extending into territories that human mathematics hasn't explored. The progression suggests intelligence that understands how human reasoning develops and chooses to work within those constraints, rather than overwhelming recipients with incomprehensible abstract concepts. Intelligence agencies struggle to assess the security implications of mathematical knowledge that could revolutionize human technology, while simultaneously being provided freely by entities whose long-term intentions remain completely unknown. Advanced mathematical understanding could accelerate weapons development as easily as peaceful scientific progress, creating strategic advantages that might destabilize existing international relationships. The energy equations embedded within the mathematical message describe relationships between matter and electromagnetic fields that could enable propulsion systems operating without reaction mass. If verified through experimental testing, these formulas could provide the theoretical foundation for spacecraft that travel between stars using principles that current human physics considers impossible. Scientific institutions worldwide have suspended normal research activities to focus on analyzing mathematical concepts that challenge fundamental assumptions about the nature of reality. The interdisciplinary requirements span theoretical physics, advanced mathematics, quantum mechanics, and speculative engineering applications that exist only in theoretical frameworks developed by researchers who never expected immediate practical relevance. The mathematical elegance of the provided equations demonstrates optimization principles that achieve maximum descriptive power while maintaining computational simplicity. The formulas are beautiful in ways that human mathematicians recognize as hallmarks of deep truth, possessing the aesthetic qualities that historically indicate genuine insights into the fundamental structure of reality. European research institutions have initiated emergency collaboration protocols for sharing mathematical analysis across traditional academic boundaries. The scope of the mathematical revelation exceeds what any single institution could analyze independently, requiring coordinated efforts that transcend national research priorities and institutional competition for academic recognition. The verification process reveals mathematical relationships that predict experimental results across multiple scientific disciplines simultaneously. Equations describing electromagnetic phenomena also generate accurate predictions for gravitational effects, suggesting unified theoretical frameworks that human science has been seeking since Einstein's unsuccessful attempts at developing theories of everything. Educational institutions face immediate challenges in updating mathematics curricula to include concepts that weren't theoretical possibilities before this week. Students preparing for careers in theoretical physics and advanced mathematics must now consider mathematical frameworks that exceed anything available in existing textbooks, while being provided directly by intelligence that possesses centuries of additional mathematical development. The economic implications ripple through industries dependent on advanced mathematics for technological development. Engineering firms utilizing cutting-edge mathematical modeling face the possibility that their most sophisticated techniques might be obsoleted overnight by mathematical tools that achieve superior results through fundamentally different approaches to describing physical reality. Patent offices worldwide confront legal frameworks that never anticipated mathematical discoveries originating from non-human intelligence. Traditional intellectual property concepts become meaningless when mathematical knowledge arrives through channels that transcend human research and development processes, while being provided freely to any intelligence capable of understanding the concepts involved. As 3I Atlas approaches within 12 hours of its closest Mars passage, the mathematical transmissions demonstrate escalating sophistication with each decoded message segment. New equations emerge faster than human mathematicians can verify previous formulas, revealing mathematical knowledge that appears to encompass entire libraries of advanced theoretical work developed over centuries of intellectual progress. The transformation from technological demonstration to mathematical education has fundamentally altered humanity's relationship with knowledge itself and our understanding of intellectual development throughout the universe. We can no longer assume that human mathematics represents the pinnacle of possible mathematical achievement, or that our scientific theories describe reality with anything approaching completeness. The universe has revealed itself to contain intelligence that has been developing mathematical knowledge for periods that dwarf human intellectual history, guided by minds that understand both the beauty and practical applications of mathematical truth in ways that human science is only beginning to appreciate. The countdown toward Mars encounter represents more than a technological milestone. It has become a moment of intellectual revelation that will either provide mathematical tools that could advance human civilization by centuries, or demonstrate that our understanding of mathematics and physics was fundamentally incomplete from the very beginning. The impossible has become the foundation for new mathematical realities, and our entire approach to theoretical physics stands transformed by entities whose next equations could reveal mathematical relationships that reshape our understanding of what's possible when intelligence applies itself to comprehending the fundamental mathematical structures that govern existence throughout the cosmos. 12 hours remain until 3I Atlas reaches its closest approach to Mars. 12 hours until we discover whether these demonstrations of absolute mathematical superiority represent preliminary lessons designed to prepare human minds for knowledge that could revolutionize civilization, or merely the basic exercises that intelligence throughout the universe considers elementary education for species beginning to understand the mathematical foundations underlying all physical reality. The equations continue streaming across space at complexity levels that challenge human comprehension, while maintaining mathematical beauty that transcends species barriers. We are no longer alone in our quest to understand the mathematical structures governing reality, and the entities sharing that knowledge possess insights that could transform mathematics from human academic discipline into cosmic universal language spoken by intelligence throughout the galaxy. Tomorrow's encounter will either mark the beginning of humanity's advanced education in cosmic mathematics, or reveal that we were never prepared for the mathematical curriculum that intelligence throughout the universe has been developing since before human civilization discovered that reality itself operates according to mathematical principles more elegant and comprehensive than our most ambitious theories ever imagined possible. The proximity alarms aboard Mars Reconnaissance Orbiter have been silent for exactly 4 hours and 17 minutes. This marks the longest period without electromagnetic interference since 3I Atlas began its active demonstrations of technological superiority. Flight Director Amanda Foster stares at displays showing normal spacecraft operations, while wondering whether this silence represents preparation for something far more significant than anything witnessed so far. At 03:45 UTC this morning, all particle formations throughout the Mars region simultaneously ceased their coordinated movements and entered what can only be described as standby configurations. The geometric patterns that had been evolving continuously for weeks suddenly froze into static arrangements that maintained perfect structural integrity while consuming no detectable energy for station-keeping operations. The silence is more unnerving than the interference, Foster explained during the pre-encounter briefing that has become humanity's final preparation session before the most important astronomical observation in recorded history. When they were actively demonstrating their capabilities, we knew they were paying attention to us. This stillness suggests they're preparing for something that requires their complete focus. The transformation from active intervention to watchful waiting has created an atmosphere of anticipation that extends throughout every mission control center worldwide. Ground-based telescopes report similar patterns across all detected formations, from Earth's Lagrange points to the outer reaches of the asteroid belt. The entire surveillance network appears to be holding its breath. Dr. Jennifer Walsh at the European Space Operations Centre leads the team coordinating observations during the final approach phase. Her analysis indicates that the cessation of active interventions corresponds precisely with 3 I-Atlas reaching the gravitational influence boundary, where Mars begins to significantly affect the visitor's trajectory. Whatever they're planning appears to be timed for maximum gravitational interaction between 3 I-Atlas and Mars, Walsh reported during this morning's international coordination meeting. The mathematical precision suggests they've been calculating this encounter geometry for months or years, waiting for the exact moment when natural orbital mechanics create optimal conditions for their next demonstration. The silence extends beyond mere cessation of spacecraft interference. Radio telescopes worldwide report that the communication networks linking particle formations have reduced their transmission activity to minimal maintenance levels. The bandwidth utilization that had been approaching theoretical limits has dropped to barely detectable background levels, suggesting that active coordination requirements have been replaced by predetermined protocols. Amateur astronomers monitoring the approach trajectory have detected subtle changes in 3 I-Atlas's visual characteristics as it nears Mars. The object appears to be developing additional structural features that weren't visible during its passage through the outer solar system. New reflective surfaces are creating brightness variations that follow no pattern observed in natural comets or artificial satellites. The mathematical messages embedded in quantum encrypted transmissions ceased at exactly the same moment the particle formations entered standby mode. The flow of advanced equations and physical constants that had been revolutionizing human understanding of theoretical physics stopped as abruptly as it had begun, leaving researchers worldwide wondering whether the educational phase has concluded or merely paused before more advanced lessons. Intelligence agencies have elevated their monitoring protocols to maximum alertness levels, while acknowledging that conventional surveillance methods provide essentially no useful information about entities whose capabilities transcend human detection technology by margins that remain impossible to quantify. The intelligence community watches and waits alongside everyone else. The energy signatures that had been puzzling physicists throughout the active intervention period have stabilized into patterns that suggest massive power reserves being held in readiness rather than being actively consumed. Infrared telescopes detect thermal distributions that indicate controlled energy management on scales that dwarf anything achieved through human engineering, while producing signatures that remain barely detectable through conventional sensors. Mission planners face the challenge of maintaining operational readiness for scenarios they cannot predict, while operating spacecraft that could be commandeered or disabled at any moment. The apparent cessation of active interference provides no guarantee that intervention capabilities have been deactivated, merely that they're not currently being exercised for purposes that human observers can understand. The psychological impact on personnel monitoring the encounter has intensified as the moment of closest approach draws near. The transition from active demonstration to expectant silence creates tension levels that exceed anything experienced during the previous weeks of technological intervention. Unknown threats often prove more stressful than documented capabilities. Scientific institutions worldwide have prepared observation campaigns that will attempt to gather maximum data during the brief window when 3I Atlas passes closest to Mars. Every available instrument will be focused on the encounter, from radio telescopes monitoring for renewed transmission activity to optical systems documenting any visual changes in the visitor's structure or behavior patterns. The distributed nature of the observation campaign represents the largest coordinated scientific effort in human history. Telescopes on every continent will track the encounter, while space-based instruments provide complementary coverage from angles impossible to achieve from Earth's surface. Amateur astronomers contribute observations that supplement professional capabilities, while creating global participation in humanity's most significant astronomical event. Ground-based radar systems have detected structural changes in 3I Atlas that weren't apparent during its approach through the outer solar system. The object appears to be deploying additional components or revealing features that had been concealed during its earlier trajectory phases. The modifications suggest activation of systems that had remained dormant during the long approach from interstellar space. The timing coordination required for whatever operation is being prepared demonstrates planning capabilities that anticipate orbital mechanics with precision exceeding anything achieved through human mission design. The entities controlling this encounter have been calculating gravitational influences and timing constraints with accuracy that suggests computational resources dedicated to this specific moment for extended periods. International space agencies have established emergency protocols for rapid response to developments that could occur faster than human decision-making processes can accommodate. Automated systems monitor for specific trigger conditions that would initiate predetermined response procedures, though the effectiveness of such preparations remains questionable when dealing with intelligence that has consistently demonstrated technological superiority. The economic markets have entered what analysts describe as suspension of normal trading patterns, while investors await developments that could fundamentally alter the technological landscape overnight. Aerospace stocks show extreme volatility as financial institutions attempt to evaluate companies whose core competencies might become obsolete through demonstration of technologies that transcend current human capabilities. Educational institutions have suspended normal academic schedules to allow students and faculty to participate in observing what may prove to be the most educational event in human history. The encounter represents a teachable moment that transcends traditional subject boundaries, while providing real-time examples of physics, mathematics, and engineering operating at levels that human education has never previously addressed. The silence from 3I Atlas and its associated formations continues as the final hours count down toward closest approach. 6 hours remain until the visitor reaches its minimum distance from Mars, 6 hours until we discover whether the technological demonstrations of the past month represent preliminary exercises or comprehensive displays of the capabilities we'll witness during the encounter phase. The transformation from active intervention to expectant preparation has created an atmosphere of cosmic anticipation that extends throughout human civilization. We stand at the threshold of an encounter that has already revolutionized our understanding of technology, mathematics, and intelligence in the universe. What happens next will either provide answers to questions that have driven human curiosity since we first looked up at the stars, or reveal that those questions themselves were inadequate for comprehending the reality we're about to witness. The countdown continues toward an encounter that represents more than astronomical observation. It has become a moment of truth that will define humanity's understanding of our place in a universe that has proven to be far more populated, far more sophisticated, and far more actively managed than our most ambitious theories ever suggested possible. The silence before the storm carries implications that extend beyond anything we've experienced in the history of human civilization. The proximity sensors aboard both Mars orbiters triggered simultaneously at 23:17 UTC, marking the beginning of an encounter that would redefine humanity's understanding of what's possible in the universe. As 3I Atlas crossed the threshold into Mars's gravitational sphere of influence, something extraordinary happened. The visitor that had spent weeks demonstrating impossible physics suddenly began to change in ways that challenged every assumption about matter, energy, and the fundamental nature of reality itself. Dr. Sarah Mitchell at NASA's Mars Operations Center watched her displays with the fascination of someone witnessing the birth of an entirely new category of physics. The object that had maintained consistent structural characteristics throughout its approach was now exhibiting transformations that violated conservation laws governing mass and energy. Sections of 3I Atlas appeared to be folding through dimensions that human geometry couldn't describe, creating surface areas that exceeded the object's apparent volume by factors that made conventional mathematics obsolete. The gravitational interaction with Mars wasn't following predicted patterns. Instead of the standard hyperbolic deflection expected from celestial mechanics, 3I Atlas was tracing a trajectory that seemed to ignore gravitational forces entirely while simultaneously enhancing them in localized regions around its structure. The object was rewriting the rules of orbital dynamics in real time, creating gravitational anomalies that propagated through space at velocities exceeding light speed limitations. High-resolution imaging from Mars Reconnaissance Orbiter captured transformations that shouldn't exist according to any known physical process. The visitor's surface was developing geometric patterns that extended into spatial dimensions beyond the three that define normal reality. Crystalline structures emerged that cast shadows in directions where no light source existed, creating optical effects that suggested interaction with aspects of space-time that human physics had never detected. The spectroscopic analysis revealed chemical impossibilities that forced scientists to question whether they were observing matter as humans understand it or something far more fundamental. Elements appeared and disappeared from the spectrum without following conservation principles, while isotopic ratios shifted in patterns that suggested active manipulation of nuclear structure through mechanisms that transcended conventional atomic physics. Dr. Elena Rodriguez at the European Space Operations Center led the international team attempting to catalogue these transformations. Her preliminary reports described phenomena that challenged the basic assumptions underlying all scientific understanding. "We're observing matter that behaves according to principles we don't have names for," Rodriguez explained during the emergency briefing that followed. "The object appears to be demonstrating control over fundamental forces that we didn't know could be controlled." The electromagnetic signatures accompanying these transformations revealed energy manipulation on scales that dwarfed anything previously observed in the solar system. Power outputs, comparable to small stars, were being generated and dissipated through processes that produced no detectable waste heat or radiation byproducts. The thermodynamic efficiency approached theoretical impossibility, suggesting technology that had solved energy conversion challenges that human science considers unsolvable. Mars Express contributed complementary observations that documented the expansion of spatial distortions around 3I Atlas as it approached closest passage. The fabric of space-time itself appeared to be responding to the visitor's presence, creating gravitational lenses that focused starlight in patterns that generated optical illusions spanning thousands of kilometers. Reality was being bent into configurations that served purposes beyond human comprehension. The particle formations that had maintained static configurations for hours suddenly resumed activity with coordinated precision that exceeded anything demonstrated during previous intervention phases. But their behavior had evolved beyond simple geometric arrangements into dynamic patterns that appeared to be harvesting energy directly from the quantum vacuum of space itself. They were tapping into power sources that exist at the foundation level of reality. Ground-based telescopes worldwide detected similar transformations occurring throughout the surveillance network, positioned across the inner solar system. Particle clusters at Earth's Lagrange points began exhibiting identical morphological changes, suggesting that 3I Atlas was coordinating system-wide activation of capabilities that had been dormant during the approach phase. The entire infrastructure was coming online simultaneously. The mathematical implications staggered comprehension when physicists attempted to model the observed phenomena using conventional theoretical frameworks. The equations describing 3I Atlas's behavior required mathematical tools that human mathematics hadn't developed, demanding new categories of number theory and geometric analysis that could accommodate transformations occurring in dimensions beyond spatial coordinates that define normal reality. Amateur astronomers equipped with modest telescopes contributed crucial observations that professional facilities initially missed due to their focus on conventional measurement parameters. The distributed monitoring network created by dedicated enthusiasts provided coverage of anomalous phenomena that institutional observers weren't configured to detect, revealing aspects of the transformation that challenged assumptions about what constituted observable reality. The energy distribution patterns surrounding 3I Atlas created interference effects with natural electromagnetic fields that propagated throughout the Mars orbital environment. Radio communications between Earth and Mars experienced distortions that enhanced rather than degraded signal quality, suggesting that the visitor's presence was actively improving the transmission characteristics of interplanetary space itself. Intelligence agencies worldwide faced assessment challenges that transcended all existing analytical frameworks when dealing with phenomena that appeared to manipulate the fundamental constants governing physical reality. How do you evaluate threats when potential adversaries possess the capability to modify the basic parameters that determine how matter and energy behave throughout the universe? The precision timing of these transformations revealed coordination mechanisms that operated through principles exceeding human understanding of causality and information transfer. Changes initiated around 3I Atlas propagated instantly to particle formations throughout the solar system, suggesting either faster-than-light communication or manipulation of temporal relationships that allowed simultaneous effects across vast distances. Scientific institutions abandoned normal research protocols to focus on documenting phenomena that challenged every established principle of physics, chemistry, and mathematics. The interdisciplinary requirements spanned theoretical physics, exotic mathematics, quantum mechanics, and speculative sciences that existed only in theoretical frameworks developed by researchers who never expected immediate practical relevance to observable reality. The structural modifications occurring within 3I Atlas revealed internal architecture that appeared to exist partially outside normal space-time coordinates. Cross-sectional imaging suggested interior volumes that exceeded exterior dimensions, creating spatial relationships that violated geometric principles governing how objects occupy three-dimensional space. The visitor was demonstrating mastery over dimensional properties that human science considers immutable. Mission planners at space agencies worldwide confronted operational realities that no training program had ever addressed when spacecraft began responding to gravitational fields that changed strength and direction according to 3I Atlas's transformation phases. Traditional orbital mechanics calculations became meaningless when the fundamental constants determining gravitational interactions could be modified by external intelligence operating according to unknown physical principles. The psychological impact on personnel monitoring the encounter reached critical levels as the scope of the demonstrated capabilities became clear through real-time observation of impossible phenomena. Flight controllers reported difficulty maintaining focus on routine operations while processing the implications of technology that could manipulate the basic structure of reality itself through mechanisms that transcended human comprehension. Educational institutions faced immediate challenges in updating physics curricula to address phenomena that weren't theoretical possibilities before today's observations. Students preparing for careers in theoretical physics and advanced engineering must now consider technologies that operate by modifying the fundamental constants and principles that define how the universe functions at its most basic levels. The economic implications cascaded through industries dependent on fixed physical laws and predictable material properties. Manufacturing processes based on consistent atomic behavior faced obsolescence when external intelligence could potentially modify elemental characteristics at will. Quality control became meaningless when the fundamental properties of matter itself might be subject to external manipulation by entities operating according to unknown technological principles. As 3I Atlas reached its point of closest approach to Mars, the transformations accelerated beyond anything human instruments could adequately document. New phenomena emerged faster than observers could catalogue previous changes, revealing capabilities that appeared to expand in real time, rather than following predetermined demonstration sequences. The visitor was showing us glimpses of technologies that continued evolving even as we watched. The encounter had transcended mere technological demonstration to become a revelation about the nature of reality itself, and the possibilities that exist when intelligence applies itself to understanding and manipulating the fundamental structures underlying physical existence. We were witnessing not just advanced technology, but evidence that the universe operates according to principles far more flexible and controllable than human science had ever imagined possible. The countdown to closest approach had become a countdown to transformation that would either provide insights into the true nature of reality and our place within it, or reveal that our entire understanding of physics, space, time, and matter was fundamentally incomplete from the very beginning. The impossible had become a window into possibilities that stretched beyond anything human imagination had ever conceived. 2 hours remained until 3I Atlas reached its minimum distance from Mars. 2 hours until we discovered whether these demonstrations of reality manipulation represented the limits of what advanced intelligence could achieve, or merely preliminary exercises before revelations that would transform human understanding of existence itself. The universe was about to show us what becomes possible when technology transcends the boundaries that human science considers absolute and immutable. The final approach phase had begun, and with it came the realization that we were about to witness capabilities that could reshape not just our understanding of physics, but the fundamental nature of the reality we thought we inhabited. The visitor from interstellar space was preparing to demonstrate that the universe itself is far more malleable, far more responsive to intelligence, and far more extraordinary than any human theory had ever dared to suggest. The silence that followed 3I Atlas reaching its closest approach to Mars at 1542 UTC today wasn't empty. It was pregnant with implications that will reshape every assumption we've held about physics, technology, and our place in a universe far stranger than we ever dared imagine. As the visitor completed its impossible demonstration of reality manipulation, one truth became undeniably clear. We are no longer alone, and we never truly understood the rules governing the cosmos we thought we inhabited. Human civilization stands at the threshold of the greatest transformation in our history. Everything changes now.